It came from the dark, an unseen wanderer crossing the endless gulf between stars, its path older than memory itself. The visitor drifted silently, unannounced, untouched by any gravity strong enough to claim it. Through the thin veil of cosmic dust, it glided, not fast by the standards of light, but still moving with a purpose written long before humans learned to watch the skies. No engine hummed, no sail unfurled, it was simply there, like a dream entering another world's sleep. The vast emptiness cradled it in silence, and even the stars seemed to hold their breath as it approached. Astronomers first noticed a flicker, a dim reflection on their sensors, something small, strange, and fast. It didn't behave like a comet or an asteroid they knew. It was moving too quickly, its trajectory curved in ways no object bound to our sun could manage. Numbers told a story of impossibility. It wasn't from here. It had come from somewhere beyond the faint edges of the solar system, from the interstellar dark that had no names, no familiar constellations. And as the world slept, computers traced its arc, revealing the truth: the visitor was merely passing through. When dawn came, the scientists who stayed up through the night watched its data unfold like a secret being told. The object had a peculiar shape, elongated, smooth, unlike any tumbling rock they had seen. It didn't shine, it reflected. And when sunlight touched it, the brightness shifted, almost as if it were rotating, showing sides of itself that glimmered and then dulled again. Each glimpse seemed to whisper of something crafted, though no one dared to say it aloud. They called it simply Oumuamua, a Hawaiian word meaning a messenger from afar, arriving first. Telescopes all over the world turned toward it, eager to catch the faintest clue. But it was already moving too fast, more than 315,000 kilometers per hour, a fleeting shadow cutting across the solar system's light. By the time most realized what it was already leaving. Still, data poured in, fragments of brightness, curves of reflection, numbers that tried to hold something that refused to be held. Each scientist stared at their monitors with quiet awe, feeling as if they were watching a letter written to humanity in a language older than stars. It didn't behave like any comet ever observed. There was no tail, no plume of gas. Yet, somehow, it accelerated slightly, as if something invisible was pushing it, or perhaps as if it was adjusting its own path. The equations didn't add up. The gentle change in speed could not be explained by gravity alone. Some suggested outgassing, like steam from melting ice. Others whispered of propulsion, though no evidence of technology could be found. But in the realm of wonder, imagination always finds a way to breathe. As the days passed, it grew fainter, its light swallowed by the background noise of the cosmos. And yet, for those who had seen it, the sense of its presence lingered, a quiet marvel that refused to fade. News spread beyond the observatories, capturing the curiosity of the world. People looked up, imagining this small, silent traveler moving past our sun, touching nothing, belonging nowhere. It reminded humanity of how vast the void truly is, and how rare a visit like this might be. Some called it an interstellar rock, a piece of another system torn loose by gravity and sent adrift. Others dreamed of it as a probe, an ancient artifact from civilizations that watched and then vanished before we were born. The truth stayed elusive, hidden beneath layers of distance and uncertainty. But what mattered most was not what it was that it came. That it existed. That space, cold and timeless, had allowed a bridge between two unknowns to briefly cross paths. Even as Oumuamua slipped away, observatories tracked its fading light until it was no longer visible. The data was archived, analyzed, and reanalyzed. Every number became a question, every anomaly, a whisper of something extraordinary. Late at night, some scientists stared at the last image, imagining the traveler moving farther and farther away, carrying its mysteries with it. Perhaps it had passed by countless stars before ours, brushing by other worlds, unseen and unnoticed. As it left, our sun's light dwindled on its surface until even that faint shimmer disappeared. It was alone again, just as it had always been. The space between stars reclaimed it, folding it back into the eternal dark. Yet, its brief passage left behind a spark of quiet wonder on a small blue planet. A sense that maybe, just maybe, we are not as isolated as we thought. For once, humanity had been visited, not by light or sound, but by motion, a soft ripple in the great ocean of the cosmos. Astronomers began searching for more. They refined their instruments, widened their gaze. If one visitor had passed, others might follow. And indeed, years later, another interstellar traveler, a comet named Borisov, would enter the solar system, carrying with it a different kind of mystery. But Oumuamua would always be the first, the one that taught us to look deeper into the dark, to notice the faintest glimmers that might one day drift our way again. In the quiet of space, the visitor continued its endless flight. It did not turn back, did not change course. Its journey was older than us, older than the sun itself. It would wander for millions of years more, maybe forever, through the black sea between stars. It was a fragment of another story, from another time, slipping past our corner of existence like a dream we were lucky enough to remember upon waking. There was something poetic in how it moved, not rushing, not wandering aimlessly, but simply gliding. Some said it seemed almost alive, responding to the sun's faint pull as though considering it before moving on. In truth, it was just physics, the delicate balance of motion and light. Yet, humans, who see meaning in the smallest spark, couldn't help but imagine intention. Maybe that was the gift of its visit, to remind us that even silence can be full of meaning. When the data was all that remained, humanity did what it always does with the unknown: it turned it into stories. Artists painted it as a shining shard of metal, poets called it a messenger between civilizations, scientists described it as a relic of cosmic birth. Each version was a reflection of ourselves, our longing for connection, for discovery, for the reassurance that we are not alone in the infinite cold. The name, Oumuamua, suited it well. It wasn't just a label, it was a whisper of reverence. It meant a scout, a messenger, but also the first to arrive. Perhaps that was the truest part of all. It had come first. Others might follow, but it would always be the one that opened the door, if only for a moment. Like the first raindrop on dry ground, it had changed how we looked at the sky. Some nights, when telescopes turned toward the stars, scientists thought of it not as data, but as a presence. A traveler who had come uninvited, passed through gently, and left behind a silence that felt somehow more meaningful than sound. The universe is not empty, they realized. It breathes in ways too slow for us to see, sending whispers across time and light. Oumuamua was one of those whispers. Even now, as it drifts far beyond Pluto's reach, it carries a part of us, our curiosity, our wonder, our quiet hope. Its visit reminded us that the cosmos does not need to shout to be heard. Sometimes it speaks through motion, through a flicker on a telescope screen, through a glimmer that vanishes too soon. And if we are patient enough, if we listen in silence, we might catch another message someday. For now, though, the visitor is gone, fading into distances too vast for thought. But its story remains, glowing softly in the collective memory of humankind. A reminder that even in the grand stillness of the universe, there are moments of encounter, brief, fragile, and profoundly moving. And perhaps, somewhere far away, Oumuamua passes another sun, another set of eyes, another curious world that looks up and wonders. Maybe it is a messenger after all, not carrying words, but carrying the simple truth that life, in all its curiosity, keeps reaching out into the dark, waiting to be met halfway. In this vast, silent sea, every visitor is a promise that the universe still has secrets to share, and that once in a great while, they choose to drift gently through our part of the cosmos, reminding us that wonder is never as far away as we think. The first images of the traveler were faint, almost ghostly. They appeared as streaks on telescope screens, mere traces of reflected light against the deep velvet of space. Scientists stared at those streaks, adjusting brightness and contrast, trying to make sense of what they were seeing. It wasn't much to look at, just a pale thread among billions of stars, but for them, it was everything. Every pixel held a question, every flicker hinted at movement. Slowly, data built a shape, or something close to one, though it was hard to tell if what they saw was real or just the universe teasing them with its mystery. Each night brought new attempts to catch it again. Telescopes turned like watchful eyes, tracking the visitor across the sky's shifting maps. They plotted its motion, drew paths and predictions, and compared them to models of comets and asteroids. Nothing fit perfectly. The object's course didn't bend like those from within the solar system, It was steeper, faster, unbound. To those who understood orbital mechanics, it was a startling realization: this was not a native of our cosmic neighborhood. It was an interstellar traveler, a wanderer from the beyond. The name came soon after, Oumuamua, chosen from Hawaiian, meaning a messenger from afar arriving first. The word carried both poetry and truth. It spoke of distance, of arrival, of something sacred. About being the first. Scientists, usually cautious in language, smiled at the name. It captured the feeling they could not express otherwise, the awe of witnessing a stranger from the deep unknown. When they spoke of it, their voices softened slightly, as if reverence was the only fitting tone. What intrigued them most was its silence. Every comet known to humankind hissed and shimmered as the sun's warmth released trapped gases. But Oumuamua remained still, no plume, no tail, no mist of dust. Its surface did not betray the heat, yet it brightened as it tumbled. Something strange was happening: its reflectivity shifted in ways that couldn't be explained by a simple rotation. The light curve suggested an elongated form, perhaps 10 times longer than it was wide. Nothing like that existed among the known bodies of the solar system. Some imagined it as a shard, maybe a fragment of a shattered world, ejected from another star's system eons ago. Others pictured it as a spindle or a flattened disk, a thin sheet of something metallic or icy. The data allowed many interpretations, none of them conclusive. That uncertainty gave space for imagination to bloom. Late at night, between calculations, even the most rational astronomers found themselves wondering, what if this object wasn't just debris, but design? What if something made it long ago, and now it was drifting, forgotten, between suns? The thought was tempting but dangerous. Science walks a thin line between curiosity and speculation. So they focused on what they could measure. They mapped its brightness, charted its acceleration, and tried to explain the gentle push it seemed to receive from the sun. Some said it must be the result of invisible gas release, others argued it was too smooth, too consistent for that. A handful quietly suggested solar radiation pressure, the same force that could push a sail in the vacuum of space. But a sail of what? Each answer opened another question, and that was the beauty of it. Oumuamua had brought not just data but wonder, a quality often missing in the sterile glow of scientific instruments. It reminded them that even in a world ruled by equations, mystery still had a place. The visitor was a reminder that not everything had to be known at once. Sometimes the universe left clues instead of conclusions, inviting us to sit with the unknown, to breathe alongside it for a while. In observatories across Earth, small groups of researchers stayed awake deep into the night. Coffee cups cooled beside notebooks filled with graphs and hand-drawn diagrams. Outside, the sky stretched endlessly, filled with light older than history itself. Somewhere out there, the visitor glided onward, unbothered by the attention it had sparked. The scientists felt a quiet kinship with it, a shared solitude, both searching for meaning in the vast dark. When more detailed analysis arrived, it painted a picture even stranger than before. Oumuamua wasn't reflecting light uniformly, its brightness varied by a factor of 10, suggesting a peculiar geometry: long, narrow, spinning erratically. It wasn't round, wasn't symmetrical, wasn't like anything humans had seen drift through their system. Its path was hyperbolic, meaning it would never return. This was a one-time encounter, a brief hello before eternity reclaimed it. There was a kind of melancholy in that. To know that something so extraordinary would come and go in the span of weeks felt almost unfair. Humanity, after thousands of years of staring at the stars, had finally been visited, and now the visitor was already fading. But that fleeting nature made it beautiful. Like a comet of meaning, it had passed close enough for us to notice, then moved on, leaving behind a trail of questions rather than dust. As its image slipped further into the archives, the excitement did not fade. New models appeared daily, each proposing a different shape, a different composition. Some suggested it was made of hydrogen ice, so delicate that sunlight itself would make it evaporate invisibly. Others argued for nitrogen ice, chipped from the surface of a long-lost exoplanet. Each theory was a reflection of human imagination trying to fill the dark with reason. But the truth remained somewhere far beyond reach, locked inside the visitor's silent journey. Even as it vanished from sight, Computers continued to simulate its path, predicting where it would go next out past the orbit of Neptune, beyond the Kuiper belt, and eventually into the interstellar medium again. It would spend millennia between stars, untouched and unseen. Perhaps someday, it might wander near another sun, another civilization curious enough to look up and wonder. And maybe they too would name it, thinking it had arrived just for them. Back on Earth, discussions turned philosophical. What did it mean for something from another star to find its way here? Was this a common occurrence, or had we witnessed something truly rare? The sheer vastness of space made such encounters improbable, yet here it was, a small, fragile piece of elsewhere, sharing our sunlight for a moment. It was as though the universe had reached out and gently tapped us on the shoulder, reminding us that we were part of something larger than our narrow orbit. In classrooms and universities, young students listened to their professors describe Oumuamua with shining eyes. The name itself became almost mythic, a symbol of interstellar curiosity. Artists drew it as a sleek monolith, writers imagined it carrying lost messages, musicians composed soundscapes inspired by its journey. In every form, it became more than a rock, it became a story, a shared moment of connection between science and wonder. But behind the fascination was also humility. Oumuamua reminded humanity that discovery often comes uninvited. We did not go seeking it, it found us. And when it came, we had only a short time to notice, to measure, to question. It was a lesson in awareness, a cosmic reminder that even the smallest flicker in the sky might hold something extraordinary, if only we're looking closely enough. As days passed, telescopes turned away, new missions demanded attention, and news cycles moved on. Yet, in quiet corners of observatories, its story lingered. The astronomers who had first seen it never quite forgot. They spoke of it in soft tones, as one might recall a dream, half real, half imagined, but always meaningful. Some even admitted they missed it, as if a friend had visited and left too soon. And while the world forgot, the sky did not. Night after night, countless other objects continued their slow orbits, but none carried the same grace, the same air of mystery. Oumuamua's uniqueness became its legacy. Its passing inspired new instruments to be built, new projects designed to detect the next interstellar messenger. Humanity was preparing for future arrivals, learning how to greet the next traveler properly. Meanwhile, Oumuamua itself moved on through the deep, endless dark. The sunlight that once touched it grew fainter until it was gone. Now only the glow of distant stars reached its surface, pale, ancient light from worlds it might never see. It drifted without sound, without purpose, yet carrying with it the quiet echo of all those who had once watched and wondered. The scientists had not found all the answers, but they had found something perhaps more precious, a renewed sense of curiosity. The visitor had reminded them that the universe was not just a place of laws and forces, but of stories and connections. It had shown that sometimes, discovery begins not with certainty, but with awe. Even now, years later, when astronomers calibrate their instruments under clear night skies, some still glance toward the patch of stars where it was last seen. They know it's long gone, far beyond the sun's reach, but the thought of it brings a faint warmth, a quiet joy that, in the vast silence of space, we were once noticed by something passing through. Perhaps that is what discovery truly means, not claiming knowledge, but sharing a moment with the unknown. Oumuamua, in all its silence, had done just that. It crossed our path and left us with wonder, a gift that would not fade with distance, but grow, carried forward by every new eye turned toward the stars. It began, as all quiet revelations do, with a glimmer. Astronomers noticed a delicate shift in brightness, a shimmer that seemed to follow the traveler as if something invisible trailed behind it. It wasn't a classic tale, not the radiant fan of ice and dust that comets wear proudly when warmed by the sun. This was subtler, softer, almost like silk in the void, an unseen hand brushing light along its path. The instruments caught it first, then the minds of those who studied it began to stir. Could Oumuamua, silent and still, have a tale after all? Comets, by nature, reveal themselves through release, through gas, through dust, through transformation under sunlight. But this visitor had no such theatrics. No plume shimmered, no haze bloomed around it. Yet, the data hinted at something more elusive, a force nudging it, ever so slightly, out of the path gravity alone could dictate. It was as though the void itself had reached out, whispering against its surface, coaxing it onward with invisible breath. The scientists, curious and cautious, turned to the oldest question in astronomy: what are we truly seeing? The models came first. Equations poured across screens, tracing faint, invisible tails, testing theories that bordered on poetry. Maybe it was releasing hydrogen, melting invisibly under the sun's touch. Maybe it was made of ices unknown to us, too delicate to show themselves in light. The numbers danced, colliding and separating like dust in sunlight. But for every explanation found, a new uncertainty took its place. The more they tried to define the tale, the less it resembled anything they'd seen before. At night, in the soft hum of observatories, scientists stared at projections of its movement. They watched the line shift, just a fraction, across black screens filled with dots. That fraction was everything, a quiet deviation that defied pure gravity. To most, it was small enough to ignore, but to those who listened closely to the universe, it was a whisper worth hearing. Something was happening, something that could not be seen yet refused to be denied. It was as if Oumuamua had found a way to move without motion, a sail with no wind, gliding on sunlight alone. Some called it radiation pressure, the same subtle force that pushes photons against the surfaces of spacecraft sails. Others hesitated: it seemed too perfect, too symmetrical, too controlled. A rock could not sail. A fragment could not steer. And yet, there it was, slipping through the sun's gravity with the grace of something that seemed to understand its own path. The line between physics and poetry blurred. It was a moment when numbers began to sound like verses, and observation turned to quiet awe. For every telescope turned toward the visitor, there were hearts equally drawn to it. People around the world read of its motion, of its strange, silk-like tail that no one could see. In it, they found comfort, a reminder that beauty can exist even in mystery. The universe didn't need to shout, it only needed to glide softly through the dark, letting us catch our breath in its passing. That faint, invisible tail became a symbol of subtle wonder, the kind that asks nothing but your stillness in return. One of the great surprises came from its acceleration. No explosion of gases, no visible thrust, yet it sped slightly faster than gravity's pull should allow. Scientists, normally grounded in equations, allowed themselves brief moments of imagination. Could it be hollow? Could its surface, smooth and reflective, act like a solar sail, capturing photons and turning them into motion? Some whispered these thoughts quietly, afraid of being labeled dreamers. But in the silence of space, even reason sometimes bows to possibility. The universe, after all, has always loved to blur the lines between what we expect and what we find. Oumuamua's silk-like tail was a metaphor for that tension, a ghost of movement, a presence felt but unseen. Every measurement only deepened the puzzle. Some data hinted that the object was losing mass, perhaps exhaling faint jets of gas. Others found no trace of material at all. It was both comet and not, both rock and dream, existing in the soft, uncertain space between definitions. As it continued outward, away from the warmth of the sun, the faint pressure that had seemed to move it began to wane. It slowed just slightly, as though satisfied with the push it had received. The data flattened, and the equations grew still. But the image, that quiet traveler with a tail of silk, lingered in the minds of those who had studied it. They had caught something rare, the grace of motion without spectacle, the elegance of mystery without proof. It was during this time that artists began to paint it differently. Some imagined a pale ribbon of light flowing behind it like the train of a gown made of stars. Others drew it as a needle cutting through cosmic cloth, leaving behind a soft wake of energy. Poets wrote of it as a sigh of the universe, gliding silently toward tomorrow. Scientists, reading those verses, found themselves nodding quietly, for the artists, in their own way, had captured what the instruments could not. Even as discussions of alien technology swirled through headlines, those who truly knew the data felt no such certainty. To them, the visitor was wondrous enough without needing fiction. The idea that sunlight alone could move a body across the stars, that such a gentle force could propel something through the void, was already miracle enough. They didn't need it to be a probe. They needed it only to be what it was, a mystery the universe had briefly shared. And yet, curiosity is a living thing. It doesn't rest quietly once awakened. Some scientists wondered if the tale, if one could call it that, was a sign of composition unknown to us. Hydrogen, perhaps, or carbon monoxide escaping invisibly. Others speculated on organic materials, dark and carbon-rich, warming under the solar glow. Each idea spun like silk itself, fine, delicate, easily torn, yet capable of weaving a picture of something greater. Weeks turned into months, and the visitor's light faded to almost nothing. But the concept of its tale refused to die. Papers continued to be written, discussions continued in quiet forums and conferences. No one could let it go. The question had become part of humanity's shared curiosity. How does something move without showing why? How can a body be both still and alive in its motion? The answers were perhaps less important than the act of wondering itself. Somewhere beyond Neptune's orbit, Oumuamua continued its silent drift. The sunlight it once reflected now reached it only faintly, as if through layers of fog. Whatever silk-like trail it carried was gone, absorbed into darkness. Yet, to those who had once tracked its passage, the image endured, an invisible thread weaving through the cosmos, delicate but unbroken. It had touched our imagination in ways that defied its smallness. Theories continued to evolve. Some proposed exotic physics, others returned to simpler truths: sublimation of unseen ices, the slow exhale of a body too cold and ancient for us to comprehend. But each attempt to pin it down only highlighted the same truth: the universe does not give away all its secrets at once. Sometimes it leaves them like silk, faint and fleeting, gliding away just as you begin to understand. In the years that followed, missions were proposed to chase such interstellar visitors. Plans emerged to launch probes fast enough to follow future travelers. Humanity had been awakened by the idea that not all comets are born from our sun's family, that some carry stories from distant stars. And perhaps one day, we would meet another with a tale that glowed, soft and silent, showing us more than numbers ever could. The memory of Oumuamua's motion became legend among astronomers. When new interns arrived, they were shown the data and told the story of the object with the invisible tail. It became a kind of lullaby within the world of science, a reminder that not everything in the sky must shout to be heard. Some wonders whisper, leaving traces you can only feel if you're quiet enough to listen. Even the sky seemed changed after its visit. Each streak of light, each passing meteor, carried a hint of something larger, a reminder that beyond our sun's glow lies an ocean where other travelers roam, unseen. Oumuamua's silk-tail legacy lived in those glances upward, in those moments of stillness when we realize that space is not empty. It's alive with stories that drift slowly past us, one at a time. And so the traveler faded, yet it never truly left. The models, the theories, the poems, they became its new form, its echo in human thought. For what is a tale, if not the mark of something once radiant, still remembered even when it's gone? Oumuamua had left such a mark, delicate, weightless, impossible to erase. Years passed, and humanity kept watching, waiting for the next faint glimmer in the dark. Perhaps another would come, perhaps one with a tale more visible, more certain. But deep down, those who remembered the first knew, nothing could match the grace of that silent passage, the way it moved like silk through starlight, showing us that even in stillness, the cosmos flows. Somewhere out there, far beyond what we can now reach, Oumuamua sails on. Its invisible tail trails behind it still, not of dust or light, but of memory, of wonder, of human curiosity stretched across the stars. It carries no message, yet it speaks endlessly, in silence, of what it means to wander. There is a particular kind of quiet that lives in the deep beyond, a hush so profound that even the passing of light feels like a whisper. Oumuamua glided through that silence, through the unseen breeze of charged particles flowing from distant suns. The space between stars is not empty, it is filled with thin streams of energy, drifting atoms, invisible winds that brush against everything daring to cross. And in that faint cosmic breath, the traveler moved like a forgotten spacecraft, its surface kissed by the gentle currents of eternity. To the instruments that tracked its fading echo, the object behaved with uncanny grace. It rolled, tumbled, yet followed its course as though guided by a subtle awareness of its surroundings. Scientists described it as a natural body, but the language of their equations could not fully capture its elegance. It was as if the universe itself had shaped it to move perfectly through these invisible seas, no resistance, no drag, no sound. The solar system's wind, born of the sun's endless exhale, wrapped around it softly before letting go. In the mind's eye, one could imagine the scene, the faint shimmer of particles drifting outward from our star, brushing against the traveler's body as it continued its journey. Like a small craft sailing on a cosmic tide, it seemed to sense each ripple of that invisible stream. There was beauty in its balance, in how it neither fought nor yielded, only moved with quiet understanding. It was not made to conquer space, but to belong to it. To those who had studied spacecraft and the physics of motion, Oumuamua's behavior stirred a strange sense of familiarity. It seemed to drift like something built to last, like an ancient probe designed not for speed, but endurance. Of course, reason reminded them that it was only rock and ice, shaped by time, not hands. And yet, the mind does not easily quiet the urge to see purpose in motion. In that stillness, it was hard not to imagine a craft, not ours, not anyone's, but one shaped by the universe itself. Spacecraft we build fight the winds of space, they maneuver, burn fuel, make noise in the language of engines. Oumuamua, however, needed none of that. Its design, if one could call it that, was simplicity itself, elongated, smooth, reflective enough to dance with sunlight. It did not resist the solar wind, it allowed itself to be carried by it. This was motion not as control, but as surrender, the same way a leaf floats along a river, carried wherever the current chooses to flow. The thought touched something deep in those who followed its path. For a moment, the mechanical became poetic. A comet, an asteroid, or perhaps a relic, whatever it was, it reminded them that travel in space need not always be a battle. Sometimes it could be a dance. Perhaps the future of exploration lay not in the force of propulsion, but in learning how to move with the universe rather than against it. In that sense, Oumuamua was a teacher as much as a visitor. If one could listen closely enough, if the silence of space could somehow be translated, perhaps it would sound like wind passing through metal, or over stone. A faint hum born not of machines, but of motion itself. Every celestial body feels it, that whisper of solar particles brushing past. Voyager, Pioneer, New Horizons, all our own messengers feel it too, their surfaces gently eroded by invisible breezes. Oumuamua was no different. It was simply older, lonelier, but carried by the same eternal wind. The comparison to our own spacecraft deepened with time. Like Voyager 2, which now drifts through interstellar space, Oumuamua had no destination, only direction. But unlike the human-made probes, it carried no instructions, no golden record, no code. Its only message was its existence. And yet, that message was profound, a cosmic whisper that said, "We are not alone in motion. Between every star, there are travelers. Some built, some born, all passing through the same quiet sea." In this way, it became more than an astronomical curiosity. It became a reflection, a mirror for the human desire to wander. For centuries, we have dreamed of leaving our home world, of sending ships through the void. And here, suddenly, came proof that something had done so long before us. Whether born of nature or time's strange design, it was a traveler, just as we hoped to be. The resemblance was not in shape, but in spirit. The cosmic breeze that carried it also revealed something about our own fragility. The particles that brushed its surface are the same that once shaped planets, the same that drift toward Earth's magnetic field even now. Space is not still, it breathes, moves, sings in frequencies too low for ears to hear. Oumuamua's passage through that unseen breath reminded us that even the emptiest stretches of reality are alive with motion, with exchange, with quiet communion. Some scientists tried to model that breeze, mapping the solar wind's fading power as it reached out beyond Pluto's orbit. They wondered how much pressure it could exert, how it might gently nudge a body across the dark. The numbers were small, impossibly so, yet they added up over time. And in that accumulation of invisible pushes lay the story of the traveler's grace. What seemed like intention might only have been patience, the willingness to move with forces too faint to see. It is said that every spacecraft hums faintly when exposed to solar particles, its instruments feeling each tremor like a pulse. Oumuamua, though unfeeling, moved with the same rhythm. In its tumbling silence, there was music, the slow waltz of inertia and wind, of light and dust. If the universe could play an instrument, perhaps this was its song, the steady, eternal motion of things too distant for sound, yet too beautiful for words. And while humans measured, calculated, and debated, Oumuamua continued, unbothered by theories. It did not care if it was a comet or a craft, an artifact or an accident. It simply was. Like a leaf in the endless river of stars, it floated onward, passing through regions where light dimmed and the sun's warmth no longer reached. The breeze became colder, thinner, but it still carried enough energy to push it gently outward, toward new and unlit horizons. Those who imagined it as a spacecraft sometimes dreamed of the beings who might have sent it. What kind of civilization would build such a thing, so silent, so subtle, so eternal? Perhaps none. Perhaps it was built not by life, but by chance, the accidental architecture of cosmic time. But perhaps, too, there was intent. Maybe, somewhere far away, another world looked to the stars as we do and sent their own small craft to drift and learn. And like us, they waited, never knowing it would never return. In those quiet speculations lay something deeply human. Our minds cannot help but seek reflection in the unknown. The image of Oumuamua as a spacecraft passing through cosmic breeze is less about what it was and more about who we are, a species learning to see itself in the great stillness, yearning for connection, imagining purpose in the endless drift. Even if it was only rock, its passage awakened something profound, a recognition of kinship with motion itself. As it drifted farther from the solar system, Oumuamua began to experience the edge of the heliopause, that invisible boundary where the sun's influence ends and interstellar space begins. The breeze changed there. It no longer came from one direction, but from many, the combined size of nearby stars, each exhaling particles into the cosmic sea. Like a lone sailor crossing into new waters, it entered a region where even light felt ancient, scattered, uncertain. The spacecrafts we've launched will one day follow it, crossing that same invisible border, feeling the same currents. In that sense, Oumuamua is not alone. It is a forerunner, a reminder that all travelers eventually leave home. The thought that it might one day drift past Voyager's silent path is strangely comforting. Two travelers, one made by stars, one made by hands, meeting briefly in the vast emptiness, sharing the same gentle wind before parting forever. Such imaginings are unprovable, but they are not meaningless. For they remind us that exploration is not only about reaching, but about being carried. The universe has its own ways of guiding what moves within it. Our ships burn and steer, but the greatest journeys, those like Oumuamua's, follow the quiet rhythm of the cosmos itself. They do not resist the breeze, they become part of it. By the time humanity forgets its name, Oumuamua will still be sailing through those distant currents. Its path may take it near other suns, where its surface will once again glow faintly with borrowed light. There, another civilization, if such exists, might catch its shimmer and wonder as we did. They might measure, question, imagine. And thus, the story of this quiet traveler will continue not as an event, but as a feeling passed between worlds. Even now, deep within our radio silence, our own spacecraft echo that lesson. They drift without guidance, listening to the breath of space as they go. Voyager, Pioneer, and New Horizons, each one a human-made dream, carried by the same winds that once brushed against Oumuamua. Together they form a kind of cosmic symphony, the song of travelers trusting the breeze. In that way, perhaps the traveler was never alone. Perhaps. The act of drifting connects all who wander, no matter their origin. Every spacecraft, every comet, every fragment of stone that leaves its home star joins the same quiet pilgrimage through the interstellar dark. And if space truly has a language, it is spoken not in words, but in the hush between them, the soft sound of motion, steady and endless. And so, Oumuamua sails on, not as a question to be solved, but as a reminder to be felt. It passes through the unseen breezes of the universe, its path unmarked yet eternal. Somewhere far ahead, it will cross into new winds, perhaps never to be seen again. But its lesson remains behind, that to travel is to listen, to drift is to belong, and that even in the vastest silence, there is movement, always gentle, always true. There are moments in history when the ticking of time becomes strangely gentle, as though the universe itself pauses to listen. The story of Oumuamua began on one such date, October 19, 2017, when the Pan-STARRS telescope in Hawaii caught a glimpse of something faint, fast, and utterly unfamiliar. Astronomers noted its strange brightness, its odd motion, and quietly marked the day, not knowing yet that the small dot in their data would grow into one of the most profound mysteries of the modern age. That date became a soft engraving on the timeline of our cosmic awareness. The record shows that it was first seen by Robert Werrick, a Canadian astronomer working with the telescope's nightly survey. His discovery was not marked by fanfare, but by curiosity. He noticed that the object's path did not align with any known asteroid or comet. It came from above the plane of planets, descending steeply before swinging around the Sun. In the early hours that followed, calculations began, and with each new number, the truth became clearer: it was moving too fast to be bound to our Sun. That realization quietly changed everything. October 20, 2017, the next date etched into the slow unfolding of the story. Data streamed in from telescopes around the world, and each observation confirmed the impossible. Oumuamua, as it was soon named, was not one of ours. Its speed, about 87 km per second, was beyond the pull of gravity that binds comets and asteroids to the solar system. It had come from somewhere else entirely, an interstellar traveler visiting us for only a fleeting moment. The name Oumuamua was chosen with care. In Hawaiian, it means a messenger from afar arriving first. The name itself felt like poetry, a soft acknowledgement that this was not merely a discovery, but a visitation. The date it received its name, October 25, carried a kind of serenity. It was as if the universe had sent a small, quiet gift, and humanity had paused just long enough to name it before it passed on. Even in the data logs and press releases, there was a hush, a sense of reverence for what the numbers revealed. As scientists retraced its path, they realized it must have entered our solar system sometime in early September, unseen, silent, moving through the darkness between Jupiter and the inner planets. On September 9, 2017, it reached its closest point to the Sun, a moment that had already come and gone before we even knew it existed. The thought carried a strange melancholy, that our visitor had already greeted our star and was on its way out before we even looked up. By October 14, it had passed near Earth, within 24 million kilometers, close, by cosmic standards, but far enough to remain safely out of reach. We only caught sight of it as it departed, a faint glimmer in the twilight of our awareness. The dates tell a story of near misses and fleeting encounters, of something ancient brushing past our world like a hand we almost held. These small numbers, written in digital logs, became the gentle punctuation marks of a cosmic tale. In November, the first studies began to appear, each date marked by growing wonder. November 1, the first detailed orbital analysis confirming its interstellar origin. November 2, the early measurements of its brightness revealing that it was oddly reflective. November 5, the discovery that its shape was unlike anything ever seen before, elongated, perhaps 10 times longer than wide. And by November 6, the world knew an interstellar object had passed through our solar system for the first time in recorded history. Each of those days carried a quiet electricity among astronomers. They worked through the nights, peering at old images to find faint traces of its earlier passage. Every rediscovered pixel of light became a moment of awe. Time, for them, became a series of soft revelations, dates transforming from ordinary calendar squares into portals of memory. These were not just scientific notes, but small moments of human astonishment preserved in data. By December 2017, as the object faded from view, the fascination deepened. On December 13, researchers noticed something peculiar. Oumuamua seemed to be accelerating slightly, as though pushed by an unseen hand. The motion could not be explained by gravity alone. Comets experience similar effects from jets of gas, but there was no visible coma, no tail, no vapor, no release of dust. The date marked the beginning of endless debates that would last for years. Time stretched into 2018, and the mystery refused to settle. On January 25, a paper appeared in Nature Astronomy, proposing that the acceleration might be due to outgassing from volatile materials. But that did not fully fit. Others argued it might be light pressure, the radiation from the sun pushing gently on a thin surface, like a solar sail. The dates piled up like quiet echoes of curiosity, each one adding another soft layer to the enigma. March 2018 brought a new kind of attention. Scientists began to openly discuss possibilities once dismissed as fantasy. Could Oumuamua be artificial? Could it be a relic of another civilization? March 14, a day that saw theoretical papers explore ideas that once belonged to science fiction. The tone was cautious, respectful, but undeniably open. The dates of those discussions remain small yet significant markers in the slow awakening of scientific imagination. April 2018, telescopes turned away as the object grew too dim to study. By then, it was already far beyond the reach of any instrument, leaving only the memory of its light. The last confirmed observation came on January 2, 2018, but its projected course was calculated long after, extending into decades ahead. Time became a thread connecting what had been seen to what would never be seen again. The data lingered, even as the object vanished into interstellar night. The next few months became an era of interpretation. May 2018, new simulations traced its possible origin, suggesting it may have been ejected from another star system millions of years ago. June, new debates about its spin, its reflective surface, its lack of dust. July, deeper questions about whether our instruments had been lucky enough to catch something truly rare or whether interstellar visitors were more common than we'd realized. By late 2018, the excitement had turned into reflection. October 2018, exactly 1 year since discovery, scientists held quiet talks about how this single event had changed the way we think of our cosmic neighborhood. There was humility in the discussions. We had seen a traveler pass by, and in doing so, we had glimpsed how small our window of awareness truly is. The date was celebrated not with spectacle, but with silence, a moment of gratitude that the universe had let us witness something so fleeting. Years passed, but the dates remained soft reminders of that brief encounter. October 2019, the announcement of a second interstellar object, Borisov, confirmed that Oumuamua was not alone. It was a moment that made the earlier discovery feel even more sacred. We had not just been visited once, the cosmos was full of wanderers, and we had only just begun to see them. By 2020, the conversations had grown philosophical. Papers written on January 10, April 13, and September 22 all explored the implications, what it meant for humanity to live in a galaxy where objects traveled between stars like seeds on the wind. Each date represented another step in the slow understanding that the boundaries between worlds are softer than we once thought. And then came the quieter years, 2021, 2022, 2023, where the focus shifted from discovery to memory. The data was analyzed, reanalyzed, modeled again, but the object itself had long vanished beyond reach. Still, the dates lived on in academic archives and in the soft memory of those who had looked at it. They remembered the long nights of watching, the gentle glow of the telescope screens, the moment they realized they were witnessing something no one else had ever seen before. Somewhere in that stretch of time, humanity began to plan. 2024, NASA announced the Comet Interceptor mission, with the dream of one day meeting another interstellar traveler up close. The dates of these plans became hopeful echoes of the first, as if time itself were looping softly, each event born from the quiet wonder of that October night in 2017. Even now, the sequence of dates unfolds like a lullaby, soft, steady, patient. From the first detection to the last sighting, from the excitement of analysis to the fading into memory, every timestamp tells a story not just of data, but of emotion. They are markers of human awe, frozen in time like constellations across the years. To read them now is to walk slowly through a gallery of moments. Each one glows faintly, not with the brightness of revelation, but with the gentleness of realization. These were the days when the world looked up and found a messenger passing through the sky, silent and swift, never to return. And as Oumuamua drifts farther away, those dates remain, quiet as footprints on sand before the tide comes in. They remind us that even in science, even in the precision of time, there is poetry. The universe speaks in numbers, but the heart remembers them as moments of wonder. One day, far in the future, another date will be added, the day humanity finally sends a ship to meet a traveler like this again. When that moment comes, the earlier ones will still whisper beneath it, soft and certain, like the rhythm of a pulse that never stopped. Until then, the story of Oumuamua is written in time itself, in the gentle unfolding of days that mark our first encounter with something from beyond. And each of those dates, though quiet and still, continues to glow faintly in the dark, the lasting signature of a brief, beautiful visit across the endless night. Though Oumuamua had long slipped beyond our reach, its presence never truly vanished. It became something unseen yet strangely near, a thought that returned in quiet hours, like the echo of a dream. It was far, impossibly far, sailing through the black corridors between stars, yet its story had rooted itself within us. People found themselves thinking about it during sleepless nights, wondering where it might be now, what silence it drifted through. It had crossed vast distances, and yet, somehow, we could still feel it. There was something oddly human in that feeling, the idea that distance doesn't always mean absence. Astronomers tracked its vanishing path in models, watching dots on screens that represented impossible expanses. And even when those dots became too faint to display, they kept tracing them anyway, as though the act of imagining could bridge the gap. Oumuamua was gone, yes, but every recalculated orbit, every whispered conversation about its nature, kept it tethered faintly to our collective mind. The numbers said it had traveled beyond the orbit of Saturn by 2020, already entering regions where sunlight dimmed into gray. The warmth of our star had faded from its surface, leaving it cold and dark. Yet, when scientists simulated its journey on computer screens, they still colored its path with gold lines, soft and luminous, as though refusing to let it become truly cold. There was something tender in that, the need to keep it glowing, even if only in memory. For the wider world, Oumuamua became a symbol of quiet wonder. People who had never looked through a telescope felt its presence through words and headlines. They saw the small artist impressions, the elongated shape, the soft light trailing behind it, and something in those images reached inward. It was easy to feel small, but also connected, to imagine that out there, in the vastness, something from another star had come close enough to see us, if only briefly. It reminded humanity that the void isn't empty, that between stars lies not silence, but motion, slow, patient, constant. Oumuamua was proof that the stars spoke to one another, that fragments of one world could pass through the domain of another. It had brushed against our neighborhood, like a traveler nodding in greeting before moving on. That gesture, though wordless, had meaning. It made people lift their eyes and wonder what else might be passing unseen. Scientists continued to calculate its distance every few months, updating charts and sending quiet updates to databases. They estimated that by late 2025, it would be nearly 5 times farther than Neptune from the Sun. The numbers, though cold, carried a kind of warmth, because they meant that someone was still thinking about it. The act of measurement became an act of care. The universe was vast, but so was the reach of human thought. In classrooms, teachers spoke of Oumuamua as though it were an old friend who had once stopped by. Children learned that space was not only about what we send outward, but what comes inward, too. They imagined the object gliding through space, silent and graceful, and felt that strange tug of connection to something both ancient and unbound. They didn't need to understand the physics to feel the awe. It was enough to know that something had crossed the gulf between stars to reach us. Writers began to weave it into stories, a quiet traveler carrying messages of time, a fragment of another sun's history. Artists painted it as a scarlet shard, or a pale beam gliding through infinite shadow. Some imagined it glowing faintly with stored warmth, as though it still remembered the light of countless worlds. Through these depictions, it remained near. The imagination became the bridge across distance, turning billions of kilometers into something touchable. At observatories, the scientists who had once tracked it often spoke of it softly, as though mentioning a loved one who had moved away. They remembered the thrill of those nights in 2017, when the data was fresh and every new number revealed something unknown. Now, the silence that followed its departure felt different, not empty, but full of quiet gratitude. The space it left behind was not void, it was memory, gently expanding with time. There were still questions, of course, scientific puzzles that refused to fade. What was its true shape? What was it made of? Was it metallic or icy, porous or solid? Some argued for hydrogen ice, others for nitrogen or carbon-rich rock. The debates continued, polite but passionate, echoing across conferences and journals. Yet behind every theory was the same unspoken truth that they all missed it, in their own quiet way. People began to realize that distance is not a wall but a mirror. In gazing after Oumuamua, we were really looking into ourselves, into our own hunger for meaning, our need to connect with something larger than our lives. Its story became a metaphor for longing, for the beautiful ache of knowing something has passed close enough to touch but will never return. The cosmos, for all its coldness, had mirrored our own yearning. Astronomers sometimes plotted its velocity just to remind themselves how vast the journey was. At over 26 kilometers per second relative to the Sun, it would take thousands of years to reach another star. They imagined it passing through unseen regions, brushing against cosmic dust, faintly illuminated by distant suns. Somewhere, perhaps, its surface carried the trace of our solar wind, a whisper of our presence clinging to it like perfume on a traveler's coat. By 2027, it would cross beyond the influence of the heliosphere, that vast bubble of particles exhaled by our Sun. Beyond that lies true interstellar space, where the winds belong to other stars, and the silence deepens into something almost sacred. Scientists marked that future date gently, knowing they would not see it happen, but comforted by the thought that the story would continue, even if unseen. It was far, yes, but we still felt its motion in the quiet hum of data. Every so often, new studies appeared, reanalyzing old numbers with better tools. Each time, the same wonder returned: we had truly seen something not born of our Sun. Even as the details shifted, the essence stayed. It had come from somewhere else, it had passed by, and we had noticed. That act of noticing made the distance bearable. It proved that awareness itself could reach across the abyss. In some ways, Oumuamua had already fulfilled what the Voyager probes were designed to do, to carry the story of one world into another star's sky. Only it had done so in reverse, arriving from elsewhere, bearing no inscription, no artifact, just existence itself. It had spoken not through technology but through movement. That simple truth lingered, that the universe communicates in ways we do not yet understand. For those who had worked closely with the data, the sense of connection persisted like an old song. They could still picture its curve, the moment it swung around the Sun, the shimmer of possibility in the graphs. They spoke of it in lectures not with technical detachment but with affection. The story of Oumuamua became one of those gentle reminders that science, at its heart, is driven by wonder. Years after it vanished, documentaries, books, and poems still appeared, all tracing the same invisible line through the stars. Each new work felt like a thread extending toward it, as though humanity kept reaching out, unwilling to let it go. And perhaps that was the truest kind of contact, not physical, but emotional, stretching across distance through shared curiosity. Some nights, stargazers still looked toward the constellation Pegasus, where Oumuamua had come from, and felt a strange intimacy with that patch of darkness. It wasn't that they expected to see it, they knew it was gone, but they liked knowing that once, something had crossed that sky and looked back, even briefly, at the small blue dot we call home. That simple thought made the night feel less empty. In time, its trajectory would take it farther than the Voyagers, deeper than any signal could reach. Yet the paradox remained that something so far could still feel so close. The heart, it seems, does not measure in light years. It measures in moments of awe, in the feeling of having witnessed something that expands the boundaries of what we thought possible. Even the quietest corners of the internet carried small echoes, images, quotes, slow animations of its path. People who had never spoken of astronomy before found themselves sharing them. It was not about the science anymore, but the sense of peace it gave. There was comfort in imagining something moving endlessly forward, untouched, unafraid, eternal in its drift. Scientists sometimes joked that it had left behind a kind of ghost, not supernatural, but emotional. The more they tried to let it go, the more its story returned. It became a lesson in humility, that not every mystery exists to be solved. Some are meant to be carried as quiet reminders of how vast and beautiful unknowing can be. And so, Oumuamua continued outward, wrapped in darkness and dust. It had no mission, no goal, and yet, in its passing, it had accomplished something extraordinary. It had connected a planet of watchers to the infinity beyond their world. It had shown that even a fragment of rock could stir hearts oceans apart. In the silence of deep space, it sailed on, far, yes, but close enough to feel. Its distance did not erase its presence. It had become part of us, stitched into the rhythm of our collective wonder, forever gliding beyond sight, carrying with it the soft, unending hum of everything we hope to understand someday. When Oumuamua slipped through the edges of our vision, the instruments stayed listening, poised like small ears pressed to the cosmic door. Even after the object had faded from the last images, telescopes remained aimed, antennas still whispered toward its direction, hoping to catch some final echo of its passage. There was a strange tenderness in that persistence, a refusal to let the silence close entirely. Machines designed for precision seemed to yearn, in their own mechanical way, to keep hearing the faint sound of a traveler now far beyond their reach. Every observatory in the network had contributed its brief glance, a flicker of light across different latitudes and longitudes. From Hawaii to Chile, from Arizona's deserts to the soft hills of Spain, they had all joined in one slow, collective act of listening. The world, for a few quiet months, behaved as a single instrument, tuned to the same cosmic note. Astronomers knew that most of what they were hearing now was noise, static and starlight tangled together, but still they listened. The act itself was sacred, almost like prayer. In those long nights, the hum of the receivers became a kind of lullaby. The data streamed in endless columns of numbers, tiny spikes and dips tracing across screens, and each trace carried hope. Somewhere in that ocean of signals might be one last reflection, one final photon scattered off the surface of the departing stranger. To catch it would be to touch it again, even if only through light delayed by millions of kilometers. That hope kept the machines alive and the people awake. The radio telescopes were the most patient listeners. Their great dishes faced the sky like open palms, collecting the faint drizzle of electromagnetic whispers. SETI's antennas, the ones that usually scanned for deliberate transmissions, turned briefly toward Oumuamua's departing trail. They found nothing but silence, a perfect, cosmic stillness that was somehow both disappointing and beautiful. The absence of sound became its own kind of message, a quiet assurance that some mysteries are meant to remain wordless. Scientists began to describe the silence as a kind of texture, not emptiness, but the presence of distance itself. The signals from stars and galaxies flooded the receivers, but none bore the faint pattern that could be tied to the interstellar visitor. And yet, the silence spoke volumes. It reminded them that the universe does not shout. It hums, it breathes, it sings in frequencies too low for comfort and too vast for translation. Oumuamua's departure simply blended into that eternal music. In some observatories, the data feeds were kept running for weeks longer than necessary, as if no one wanted to be the one to stop listening. The technicians said it felt wrong to close the session, like ending a song before the last note had faded. They waited until the object's predicted signal would have dropped below any possible detection threshold, and even then, they left the receivers open a little longer, just in case the universe had one last whisper left. There were moments when strange blips appeared, brief, sharp rises in signal strength that made hearts leap. But each was explained away soon enough: a satellite reflection, a pulse of solar wind, a meteor streaking somewhere unseen. Still, those fleeting seconds felt electric. It was comforting to imagine, if only for an instant, that Oumuamua had somehow spoken, that its journey through the cosmic sea had left ripples for us to hear. The data archives grew immense. Terabytes of noise and faint signals were stored away, labeled, time-stamped, and preserved. Some of those recordings were later turned into sound, the frequencies shifted into the range of human hearing. What emerged was a deep, meditative hum, filled with faint bursts and sighs. People who listened to those recordings said they could almost feel the motion of the traveler in them, like the sound of wind across a vast, empty plain. Even long after the search ended, the instruments kept being described as listening. Scientists knew that was a metaphor, but they used it anyway, because it felt true. The dishes were ears, the sensors were fingertips, the data streams were memories. In their precision and patience, they embodied humanity's gentlest instinct, the desire to listen to what we do not yet understand. Somewhere deep in those archives lay the faint traces of the original discovery, the raw light curves from October 2017, the brightness changes that first revealed its strange, tumbling spin. Those graphs were studied again and again, each small dip and rise examined like a heartbeat. And in a way, it was one not of life, but of motion, of existence acknowledged. The instruments had heard the heartbeat of a worldless object, and now, all they could do was remember it. When people spoke of listening to the stars, they often meant radio astronomy, but with Oumuamua, it became something more emotional. It was about listening to absence, to the spaces between signals, to the echoes that never came. To listen was to stay connected, to remain humble before the immensity that surrounded us. The instruments, for all their precision, became symbols of longing, of curiosity stretched to its most fragile limit. Years passed, and new missions took their place, new targets claimed the sky. Yet, when engineers calibrated new receivers, they often used Oumuamua's data as a reference, a kind of ghost frequency against which the noise floor could be measured. In that way, it lived on not as an object, but as a calibration tone woven into the rhythm of science. Every new ear pointed skyward carried its echo within it. There was talk of building even more sensitive detectors, ones that could catch the faint light of interstellar wanderers as they approached, perhaps even before they crossed into our system. The thought thrilled astronomers, to hear the next traveler before it passed by unseen. Each blueprint and simulation felt like a promise that next time, the listening would be clearer, deeper, more complete. Humanity would be ready to hear. But for all the technical progress, something older endured, the sense that our instruments were not just tools but companions. They had become our extensions, our cosmic senses stretched across light years. When Oumuamua had come and gone, it wasn't just a telescope that had seen it, it was all of us, through the delicate nerves of our machines. The world had reached upward with metal ears and caught a whisper of forever. Late at night, some scientists replayed the old observation data, not because they expected new results, but because it felt comforting. Watching those small fluctuations in light was like watching waves on a distant shore. The rhythm was steady, hypnotic. Somewhere beyond all those numbers, they could still imagine the faint gleam of the object tumbling, indifferent yet somehow intimate, against the dark canvas of interstellar space. The recordings that had once been raw data were sometimes transformed into art. Musicians turned frequency graphs into melodies, sound designers made ambient tracks from the noise. In museums and planetariums, people sat beneath domes of stars and listened to the sound of Oumuamua. It was not music in any conventional sense, more like a pulse, a breath, a shimmer. It lulled audiences into silence, reminding them that listening is its own form of wonder. Even among those who had nothing to do with science, the metaphor of instruments as ears found resonance. It became a phrase for how we reach into the unknown with patience, not with conquest. Just as our ears are attuned to faint vibrations, so our instruments must be tuned to the quietest truths. Oumuamua had taught us that sometimes, the universe does not announce its miracles. You must simply be still enough to notice the whisper. When astronomers gathered years later to commemorate the discovery, they played those sounds once more, the gentle hum of space, the faint hiss of radiation. In the silence that followed, someone said softly, "It's still out there." And though they knew how far it was, they all felt it. The room seemed smaller, the stars closer, the distance between human hearts and cosmic dust suddenly thinner than ever before. There's a kind of intimacy in data, a tenderness in the act of measuring. Those who worked with Oumuamua's numbers understood this deeply. Every graph, every recalculated orbit, was an act of care, a form of listening continued long after the sound was gone. The instruments may have fallen silent, but their listening had awakened something in us that did not fade. Across the years, as new discoveries came, each was greeted with the same hush that had followed Oumuamua's passage. It had changed how we listened, teaching us to attend not only to what shines brightly, but to what passes quietly. The next visitor, when it came, would not go unnoticed. We had learned patience. We had learned to hear the dark. And perhaps that is what the instruments had been waiting for all along, not a message, but a transformation. To listen to space is to change how you feel about silence itself. The antennas, the sensors, the long hours of waiting, all of it had been a mirror for our own hunger to connect. Oumuamua had passed, but its silence had taught us how to listen. Some say that the universe has no sound, that space is a vacuum where nothing can be heard. But that isn't true, not entirely. Space hums, whispers, glows with energy. The instruments hear it constantly, the background murmur of creation itself. Oumuamua had moved through that murmur, brushing against it like a note drifting through a song. We, through our tiny ears of metal and glass, caught just enough to feel its passing. Now, as it drifts beyond the heliosphere, the data grows still. Yet somewhere, deep in the archives, the hum remains, waiting to be replayed by another generation. They will listen, and for a moment, they too will hear what it meant to be alive at the moment when humanity first realized that visitors come not just from our skies, but from the stars beyond. And in that long, patient listening, the universe itself seems to breathe. Our instruments, poised like tiny ears, have not only heard the silence of a passing traveler. They have heard us, too, the small, unending wonder of a species learning to listen softly to the infinite. When scientists first imagined what it might be like to pass through the tail of a comet, they pictured chaos, streaks of dust, streaming gases, and ice scattering like glitter across darkness. But when spacecraft actually did, they found something subtler. The tail was not a violent storm, but a whisper of matter, a flowing, almost invisible current, so thin it could drift through your skin without you ever feeling it. The universe, it seemed, spoke softly even when it moved fast. The tail wasn't a wall, but a breath. In the 1980s, when the Giotto spacecraft flew through Halley's Comet's tail, humanity learned what passing through truly meant. The particles struck like slow rain, not bullets. They etched delicate scars on the craft's shielding and left behind traces of ancient chemistry, materials older than Earth itself. It was as if Giotto had brushed its metallic fingers across the universe's oldest skin, collecting whispers of what once floated between the stars. Each dust grain told a story of frozen time, untouched for billions of years. The data that came back was astonishing. Scientists saw the fingerprints of organic compounds, the same building blocks that, long ago, may have seeded worlds like ours. Comet tails, they realized, were not just icy remnants of the solar system's birth, they were messengers, carrying recipes for life. To pass through one was to fly through history. A trail of molecules shaped before memory began. The spacecraft became both explorer and archivist, gathering fragments of the past as it moved forward. But the lesson of passing through a tail wasn't only about what was found. It was also about humility. The tail stretched millions of kilometers wide, yet the spacecraft touched only a thread of it, a thin ripple of dust out of an ocean unseen. And still, that thread was enough to teach humanity how little we truly know of the spaces between stars. Every grain of dust in that vast stream was like a syllable from a language we're still learning to read. When Oumuamua passed through the inner solar system, some scientists wondered whether Earth might have crossed its faint, invisible trail. If it had left any gases or particles behind, they would have been too diffuse to touch, yet the thought alone stirred awe. Imagine the planet drifting for an instant through the wake of something born between stars. Even if no molecules reached us, perhaps some trace of its passage still brushed the solar wind, faint and electric. To pass through a tail is to experience presence without collision, to be near something ancient and vast without disturbing it. The spacecraft that had done so became witnesses to grace in motion. Each time, the instruments recorded a different rhythm, ions flowing like breath, dust streaming like silk, sunlight breaking into faint glows. The tail was not destruction but transformation, a meeting place between light and matter. The particles themselves were wanderers too. Ejected from the nucleus, they joined the solar wind and rode outward, becoming part of a cosmic flow that never stops. In a way, they were travelers like Oumuamua, small, unanchored, destined to drift until they burned in sunlight or dissolved into shadow. Every tail in the sky was a reminder of motion, of how nothing in space is still for long. Spacecraft engineers spoke of these encounters with a kind of reverence. They described how the instruments would suddenly come alive, their sensors tingling with readings that shifted every second. The dust counters ticked softly like rain on a roof. The plasma detectors sang in fluctuating tones. It was as though the comet's breath had turned the machinery into an instrument, playing the faintest cosmic melody as it passed. The encounters changed how scientists thought about space. Before, the void had seemed empty, silent, vast, unchanging. But passing through a tail revealed its hidden textures. Even emptiness, it turned out, had weight and taste. The vacuum shimmered with invisible trails of atoms and ions, flowing between worlds like unseen rivers. And suddenly, space felt less like a desert and more like an ocean, quiet, yes, but full of drifting life and movement. There was also a strange poetry to how fragile these tails were. They appeared brilliant in the night sky, but their brightness came from scattering, from sunlight glancing off countless tiny shards. A gust of solar wind could reshape them. A turn of the nucleus could bend them like ribbons. What we saw from Earth was a reflection of constant change, beauty born from impermanence. The spacecraft passing through them became momentary witnesses to that truth. Scientists often described the experience as listening with the body. The spacecraft didn't just see or measure, it felt. Dust hit, electrons hummed, and sensors vibrated. It was like running your hands through starlight, dangerous, delicate, mesmerizing. What they brought back wasn't only data, but sensation. Numbers turned into feelings, voltages into wonder. It reminded everyone that discovery isn't only a matter of intellect, it's also a matter of awe. Even after the missions ended, the data from those crossings continued to teach. New simulations of comet tails used Giotto's recordings, stardust samples, and Rosetta's whispers. They showed that these tails weren't chaotic after all. They followed subtle patterns, shaped by electric fields, solar tides, and invisible magnetic threads. The tails had structure, faint, elegant order beneath their shimmering chaos. For students studying those recordings decades later, it felt like listening to an ancient conversation. Each data point was a word, each fluctuation a pause. The comets had spoken once, softly, and the instruments had heard. Even now, as those comets moved far from the sun again, their stories continued to unfold through analysis, revealing new insights about the origins of matter and motion. Oumuamua, though, had no visible tail, no glittering stream to trace, no particles to collect. That absence itself was a teaching. It showed that not all travelers leave trails we can see. Some move silently, shaped by ice that never melted or rock that never glowed. Its quietness reminded scientists that not every message comes wrapped in light. Some arrive in silence, waiting to be understood later, through reflection rather than observation. And yet, metaphorically, Oumuamua did have a tail not of dust, but of curiosity. Its passage left behind a wake of questions, new missions, and countless dreams. The scientists who studied comet tails were among the first to say it. Perhaps our instruments should be ready not just for comets, but for interstellar wanderers too. Each encounter, whether with dust or with mystery, becomes a rehearsal for the next. Passing through a tail also teaches patience. It takes time to understand what you've touched. The data doesn't reveal itself all at once, it unfolds over years, through quiet study. The first readings may seem meaningless, but then a pattern emerges, a curve, a rhythm. Discovery, like drifting through dust, happens gently. The universe rarely shouts its truths, it lets them fall, one grain at a time. Those who've watched the data come in speak of how beautiful it is to see cosmic material interact with sunlight. Dust particles, though microscopic, scatter light into colors the human eye can't perceive: ultraviolet blues, infrared reds, wavelengths beyond seeing. Instruments catch those hues and turn them into numbers, and scientists, in turn, translate them back into beauty. It's as though machines and humans collaborate to see what neither could alone. Every tail crossing brings the same lesson: proximity without grasp. We come close to understanding, but never quite touch the heart of what we seek. That distance is not failure, it is balance. The universe keeps its mysteries not out of cruelty, but out of grace. To pass through a tail is to experience wonder without possession, closeness without capture. It reminds us that not all contact requires control. Even the smallest particles found in those tails have changed how we think about beginnings. Within them are isotopes that trace back to ancient stars. Debris from explosions that predate our sun passing through them means touching the ashes of creation itself, the dust that once floated in the nebula where our world was born. Every spacecraft that brushed a comet's trail carried back a handful of cosmic ancestry. In classrooms and observatories, young astronomers now learn about these passages as sacred moments in science. They study not only the numbers but the feeling, the fragile awe that accompanies contact with the infinite. In that humility lies a new kind of wisdom, the understanding that discovery and reverence can coexist. And perhaps the greatest lesson is this: when you pass through a tail, you don't just learn about what's out there. You learn about yourself. You learn how small your tools are, how vast your reach can be, and how the act of listening can make even emptiness seem alive. Spacecraft become mirrors, reflecting our curiosity back to us, refined and shining. When humanity sends its next probe toward an interstellar object, it will remember these earlier passages, the soft collisions, the faint glows, the fragile dust. It will know to listen differently, to sense the invisible, to read silence as data. For every journey through a comet's tail has taught us the same truth, that the universe's greatest wisdom is not in noise, but in stillness. One day, another traveler may come, trailing a thin ribbon of gas, and our instruments will be ready to pass through it again. And when they do, the sensors will awaken, the numbers will flow, and we will once more hear the quiet music of motion, the eternal lesson carried in the drifting tales of wanderers. And in that passage, the universe will remind us that to learn is to move through wonder, to drift gently, to listen deeply, and to let even the softest dust of distant travelers change the way we see the stars. When Oumuamua drifted through our solar system, it wasn't merely a visitor. It was an invitation, a rare, fleeting chance to observe something untouched by our sun's long reach. Astronomers called it an opportunity, but the word felt too small. It was as if the cosmos itself had paused for a moment, allowing us a glimpse of its private history. For a few short weeks, we were close enough to something older than any planet, and its passage through our neighborhood became a quiet, celestial kindness. Opportunities like that are rare not because the universe is stingy, but because time itself is patient. Oumuamua's journey began before life on Earth had formed, and its crossing of our system lasted only days in cosmic terms. To study it was like hearing a single note in a song billions of years long. Yet, in that small moment, humanity leaned forward with every instrument it had, determined to capture the sound before it faded into silence again. The first telescopes that caught sight of it did so almost by accident, small observatories scanning for near-Earth asteroids. When the data came in, and the orbit was plotted, there was a pause that spread like a ripple through the community. Its path didn't loop around the sun as asteroids do. It was hyperbolic, open-ended, the trajectory of something unbound. The realization was gentle but seismic. For the first time, we were watching an object from another star pass us by. That realization filled the nights with a tender kind of urgency. Observatories all over the world turned toward the coordinates, adjusting filters, calculating exposure times, racing against the inevitable dimming as it sped away. Scientists spoke softly during those nights, as though afraid to startle the visitor. Every photon counted. Every bit of light captured in those brief weeks became a piece of cosmic evidence, proof that something from far away had brushed against our awareness. But there was something deeper beneath the data, a feeling that the universe had opened a small window just wide enough for us to see through. For generations, humans had looked outward, wondering if the space between stars ever sent anything back. Oumuamua was the answer, unplanned and unannounced, drifting silently into our sight. It was as though the stars had written a letter and left it on our doorstep. Astronomers often described the experience as bittersweet. Here was the first interstellar object ever detected, yet it was already leaving. The telescopes could barely keep up as it faded. Observing it was like trying to hold a candle in a strong wind. The more they looked, the dimmer it grew. But in that fading light, something beautiful happened. The community became united, not by competition, but by shared wonder. Every observatory, every instrument, contributed a verse to the same story. The rarest opportunities are the ones that can't be repeated. Oumuamua would never return. Once it crossed the heliopause, it would be gone forever, a streak of memory vanishing into the dark. Knowing that made every moment precious. Scientists double-checked their measurements, recalibrated instruments, ran late into the night. They weren't chasing fame, they were trying to honor the privilege of being alive at the exact moment this happened. The photographs, though grainy, carried an intimacy that no clarity could improve. A small streak of light across a dark field, that was all it was. Yet within that streak lay meaning enough to shake our understanding of the cosmos. The fact that it existed at all, that something from another system could cross ours, meant the galaxy was not a sealed chamber but a living sea, filled with drifting fragments of stories we had yet to read. Some scientists described the experience as standing in the rain after years of drought. For so long, humanity had stared outward with empty hands, and suddenly, a drop had fallen into our palm. Small, yes, fleeting, yes, but real. Oumuamua's passage became a proof of possibility, a reminder that interstellar space was not unreachable. We weren't alone in motion, everything moved together, slowly, gracefully, through the same cosmic tide. The opportunity was also emotional in ways that surprised even the most rational minds. Astronomers, usually trained to speak in careful terms, began to use words like beautiful, poetic, and fragile. It was as if the discovery had reminded them that behind every calculation lies longing, a human desire to touch something beyond the self. Science, for all its precision, has always been a language of yearning. Oumuamua simply made that longing visible again. As more data came in, the mystery deepened. Its brightness fluctuated strangely, suggesting a tumbling shape, elongated and uneven. It didn't behave like any asteroid we had seen. It had no tail, no visible coma, and yet it glowed faintly, as though light itself couldn't quite decide how to leave its surface. Every new image added questions rather than answers. And that uncertainty became part of the wonder, the reminder that opportunity is not about certainty, but about curiosity awakened. For the younger scientists, it was a moment that would define their generation. They watched in real time as history unfolded, their laptops filled with raw data that no one had ever seen before. They knew they were witnessing something that would be studied for centuries. It was humbling to realize that even with all our technology, we could only watch the visitor fade. But that limitation didn't feel like loss, it felt like reverence. The astronomers began to speak of it not as a discovery, but as a meeting. And like all meaningful meetings, it was brief, surprising, and transformative. Some compared it to seeing a wild creature pass at the edge of a forest, close enough to glimpse, too distant to touch. You don't chase such a moment, you honor it by watching quietly, by letting it pass with grace. Even after it vanished from view, the data kept whispering. Teams continued to analyze its light curves, its trajectory, its color. The numbers told stories about density, composition, and origin, but beneath them lay a softer truth that we had been given a chance to feel. Small in a new way. Not diminished, but connected. The universe had brushed against our awareness, and we had listened. Opportunities like this remind us that discovery is not control, it's conversation. The cosmos doesn't yield to us, it speaks briefly and then moves on. Our role is not to grasp, but to hear. Oumuamua passed through our solar system like a word spoken once and never repeated, but the echo of that word continues to guide us. Every future mission, every telescope pointed outward, carries a trace of its passing. When the reports were finally published, they read like love letters to the unknown. An interstellar object, they began, simple words, but heavy with meaning. It was the first time such a phrase had ever been written with proof. The universe had always been imagined as shared, but now it was confirmed. The spaces between stars were not empty, they were highways of possibility. The tenderness of that realization lingered. For weeks afterward, astronomers found themselves speaking more softly, as though still under the spell of the visitor's silence. Some even dreamed about it, a long, thin shape gliding through starlight, untouchable yet familiar. The human mind, it seems, could not let go of the moment when the infinite had briefly turned its face toward us. And though the opportunity was scientific, it was also spiritual. It reminded us that the universe still has surprises, that even in an age of data and algorithms, there are moments that can only be met with awe. To see something never seen before is to be reborn for a moment, to realize that the sky still holds wonders that don't belong to our expectations. Years later, when newer interstellar objects would be discovered, they would be compared to Oumuamua. But nothing could replicate that first encounter. First times are always sacred, the moment when an idea steps into reality. That was what this passing truly was, a bridge between imagination and evidence, between longing and understanding. The opportunity also reshaped how we thought about travel. For decades, humanity had dreamed of sending probes beyond our solar system. Oumuamua showed that objects could come the other way. It suggested a cosmic exchange already in motion, material, memory, and motion moving freely between stars. We were not isolated, we were part of a vast, unseen migration. And perhaps the tenderness of the moment came from that recognition that we had been noticed, not in the way of eyes meeting, but in the way of paths crossing. The object had no intention, no message, and yet its very presence felt like communication. Sometimes, the act of simply existing in proximity is enough to change everything. When people looked back on those weeks, they often described them as slow. Not because time actually slowed, but because awareness did. The nights stretched longer, the stars seemed closer, and the act of watching became a kind of meditation. The universe had offered a fleeting moment of stillness amid its infinite motion. To call it rare is to acknowledge its fragility. To call it tender is to admit what it did to our hearts. Oumuamua's visit wasn't about discovery alone, it was about grace, the quiet, unrepeatable grace of being present at the right time in the endless drift of things. Science gave it context, but wonder gave it meaning. And when the data finally stopped, when the telescopes turned away, there was a moment of collective silence, not disappointment, but gratitude. We had looked, we had learned, and now we had to let it go. The sky closed around its absence, and yet something in us remained open. That is what rare opportunities do, they remind us of our capacity for wonder. They teach us that even in an infinite universe, moments of connection can exist, brief and bright as sparks. Oumuamua was one such spark, crossing the darkness, leaving behind a trail not of light, but of quiet awakening. And as it faded into the distance, its lesson lingered, that sometimes, the most extraordinary gifts arrive unannounced, stay only for a breath, and yet leave us changed forever, aware, listening, and deeply, tenderly alive beneath the stars. When news of Oumuamua first reached the public, a wave of curiosity was followed, naturally, by unease. A visitor from another star, the phrase alone stirred imagination and fear in equal measure. But scientists were calm, almost serene. They reassured everyone, there was no danger, no need to worry. This was not a collision, not a threat. It was a passage, silent and distant, as harmless as the shadow of a cloud drifting across a mountain. The universe had simply brushed against us in the gentlest way possible. Oumuamua's trajectory was precise and peaceful. It would pass far from any planet, far from our world, untouched and unthreatening. The calculations were exact, the path clean. The object was fast, too fast to be caught, too light to cause harm. Even as it entered our solar system, it never veered, never faltered, never gave any sign of interaction beyond its graceful motion through the sunlight. It was as though it had rehearsed this journey long before we ever existed. The scientists' confidence came not from wishful thinking, but from data, beautiful, orderly numbers tracing the object's path through the void. They knew how to read motion, they could feel safety written in the arcs of its speed and distance. Every hour, new measurements confirmed what the first had shown, it was simply passing through. The mathematics of serenity, plotted against the backdrop of infinity. There was, however, something soothing beyond the calculations. It was the nature of the encounter itself, how softly it had arrived, how quietly it would leave. No flare, no storm, no disturbance. Even the sun's gravity, powerful and commanding, only bent its course slightly, like wind curling around a stone. The harmony of physics was in full display, even in movement, there was respect. The visitor obeyed the quiet laws of the cosmos, and in doing so, reminded us that most of the universe is peaceful. Public imagination, of course, tends to wander toward worry. Some wondered if it was a probe, or something alive, or perhaps a fragment of an ancient ship. But those closest to the data smiled softly at those thoughts. There was no radio emission, no engine, no sign of intent. Oumuamua was beautiful precisely because it was unbothered by us. Its silence was natural, its behavior pure. Sometimes, the most comforting truth is that not everything is about us. The calm certainty spread through the scientific community like a balm. This was a rare event, yes, but not a perilous one. The world could look up, admire, and rest easy. There was no impact risk, no apocalypse hiding in the numbers. It was simply a traveler moving past, invisible to most eyes, seen only by those who watched the heavens closely. The sky, for all its mysteries, remained a safe place that night. And so, as observatories tracked its course, the mood was gentle, not alarm, but wonder. The astronomers joked quietly in their control rooms, sipping coffee under screens full of stars. They felt the strange privilege of witnessing something historic without having to fear it. That balance, or without danger, is rare, and it softened the long nights into something like peace. The sense of safety was also philosophical. Oumuamua reminded us that the universe is vast beyond imagining. Distances between stars are measured in light-years, and the odds of collision are almost non-existent. We live, in truth, inside an ocean of space so wide that even the fastest travelers can only graze us lightly. It is an immensity that shelters as much as it humbles. To know that something can pass so close, yet leave us untouched, is strangely reassuring. It speaks to the quiet order of cosmic motion, how gravity choreographs even the wildest trajectories into harmony. Nothing in its path was threatened, nothing had to change. The solar system absorbed the encounter like a breath, then exhaled. Safety, it turns out, can be beautiful. Even the media, often drawn to dramatization, found it hard to turn this event into fear. The facts themselves were calming. The object was small, the path stable, the danger absent. Scientists spoke gently in interviews, describing it as passing through peacefully. The phrase caught on. Children who heard the story slept soundly. Adults, too, felt a kind of quiet pride. Humanity had seen something immense, and it had smiled at us as it drifted away. But beneath that surface of calm, there was also a deeper lesson that safety isn't the absence of contact, but the presence of understanding. We feared what we did not know, and as soon as we learned, the fear faded. Knowledge, in its purest form, is comfort. Once the numbers aligned and the object's orbit was mapped, the anxiety dissolved into awe. The unknown had become the familiar, and the familiar had become wondrous. Some compared Oumuamua to a leaf floating on a great river, our solar system being only a small eddy in that flow. The leaf brushed past, graceful, untouching, unhurried. It was never meant to strike anything, it simply followed the current written into its motion. And in that simple act of drifting, it showed us how vast and calm the currents of the cosmos truly are. Even as it left, its presence brought comfort. Scientists knew it would not return, but the fact that we had seen it once meant we could see others again. The universe, far from being a chaotic or hostile expanse, revealed itself as a place of order and balance. If something could cross light years and still slip by us so smoothly, then space itself must be a place of extraordinary stillness, a sanctuary for motion. Some found poetry in that thought, that even in the infinite cold, there is grace. Nothing hurried. Nothing collides needlessly. Everything, from the smallest dust grain to the largest planet, moves in quiet accord. Oumuamua was not an intruder, but a guest, one who knew the etiquette of silence. And so, instead of fear, it left behind serenity. Astronomers often said that watching it pass felt like being trusted. The cosmos had allowed us to see one of its secrets without being harmed by it. It was a reminder that the universe doesn't threaten us as often as we imagine. It simply exists, vast, indifferent, yet somehow kind in its indifference. Safety, they realized, isn't always the result of walls, sometimes, it's the product of scale. When people asked if more visitors would come, scientists said yes, likely many. But there was no alarm in their voices. The sky is full of travelers, most of them unseen, all of them harmless. We are part of a great, slow dance of objects, each obeying quiet laws, each crossing paths without collision. To exist within such an orchestra is to be surrounded by safety woven from mathematics and time. And still, there was something emotionally tender about that reassurance. To know we are small and yet protected, that the universe does not conspire against us, felt like an act of grace. The stars were not watching us with malice, they were simply burning, glowing, breathing in silence. The cosmos is not a battlefield, it is a cathedral. Every orbit, every trajectory, an act of quiet faith. When the last observations of Oumuamua came through, the screens filled with the faintest speck, a whisper of light on the edge of visibility. And yet, in that whisper, there was calm. It was leaving exactly as it had arrived, gently, predictably, safely. The engineers nodded, the astronomers smiled, and somewhere deep inside, everyone felt lighter. The universe had moved, and we were still whole. That night, in observatories across the world, there was a sense of closure. No alarms, no urgency, only gratitude. The data had been gathered, the trajectory confirmed, and the mystery preserved. Safety had been not just a condition, but a feeling, the awareness that we had shared space with something extraordinary and come away unharmed, even enriched. The lesson endured long after the visitor was gone. Each new discovery carried echoes of that calm. When the next interstellar object appeared, 2I Borisov, people remembered the first one and smiled. They knew what to expect. The universe had given them practice in peace. Once you have seen a traveler pass safely, you stop fearing the dark between stars. Even the concept of cosmic danger began to feel smaller. The more we learned, the clearer it became that threats in space are rare, and harmony is the rule. The stars and their debris coexist in vast equilibrium, guided by gravity's patient hand. We live inside a balance so precise that even the wildest travelers find paths that avoid harm. That realization became a quiet comfort woven into the heart of science. Children learning about Oumuamua in classrooms were told the same word scientists once spoke: it's safe. There's no need to worry. And those words, though simple, carried power. They taught a generation that not all mysteries are dangerous, that sometimes the unknown arrives as a gift, not a warning. Curiosity and calm can coexist. Safety, in this story, became something poetic, not the absence of motion, but the harmony within it. The universe is always moving, always flowing, and yet most of it passes through itself without harm. Oumuamua was proof of that deep equilibrium, a gesture of reassurance from the cosmos itself, telling us, it's all right to look, to wonder, to breathe. And in that reassurance lay a kind of love, not the emotional kind, but the vast, impersonal kindness of nature doing what it does best, existing beautifully without threat. It was a reminder that we, too, are part of that peace, moving safely within its grand and silent machinery. The scientists who had tracked it still remember those nights with warmth. They speak not of fear or urgency, but of calm precision, a sense of being held in rhythm with something much larger. Safety, for them, was not merely a prediction, it was an experience. They had witnessed serenity in motion. Even now, when people ask about the object, the answer remains the same. It came, it passed, it left, and nothing was disturbed. That simplicity is its beauty. It reminds us that not every encounter with the vast has to end in drama. Sometimes, it ends in peace. And so, whenever the thought of distant visitors returns, we remember Oumuamua, the first, the harmless, the gentle. We remember the calm with which it crossed our sky, and the grace with which it left. It taught us, in its silence, that the universe is not always something to survive. Sometimes, it's something to rest within. Before a spacecraft ever opens its instruments to the sky, there is a rhythm of quiet preparation that begins long before the launch, long before the first light of discovery. Scientists, engineers, and planners move like clockwork through countless checklists, rehearsing every possibility. They do not rush, because the universe cannot be rushed. Every calibration, every test, every quiet nod exchanged in a lab is an act of patience, a small prayer to precision. To prepare for the unknown, one must first learn how to move slowly. The people behind such missions understand the fragility of their tools. In space, one loose screw or one misaligned sensor can mean silence forever. So they double-check, then check again, until muscle memory and instinct merge into confidence. Each component is assembled like a heartbeat. Each connection hums faintly with the promise of endurance. The spacecraft may be small, but the care poured into it is infinite. Every line of code, every cable, every panel of metal is touched with reverence. Long before the launch day, the rooms where these people work are filled with low voices, not excitement but focus. Monitors glow in shades of blue and white, and on those screens, models of trajectories spin gently. The teams stare at those moving lines as though they are living things, fragile, luminous paths that must thread through darkness. The mathematics becomes a kind of meditation. They speak to each other in soft technical terms, their words carrying weight like stones set in a temple wall. Every mission, whether chasing a comet's tail or listening for a faint signal from deep space, begins with repetition. They simulate again, and repeat until the mind grows still. Mistakes are not failures, they are lessons folded carefully into better plans. When the day of execution finally comes, there is a strange calm that fills the air, a silence not of anxiety, but of readiness. The world outside may move fast, but inside these control rooms, time flows differently. There is something profoundly human about this patience. Machines may travel far, but it is human steadiness that gets them there. The teams who guide these missions know that haste breaks what the universe teaches through stillness. So they slow down to match the rhythm of space itself, long arcs, measured light, careful timing. Precision is not mechanical, it is emotional discipline. It is the ability to stay calm while waiting for an answer that may take years to arrive. When Oumuamua appeared, these teams already knew how to move. They had practiced this kind of listening, this kind of delicate readiness, for decades. The object was fleeting, and the window of study was small, but the scientists' preparation turned that brief encounter into history. They didn't scramble, they flowed. Observatories across the planet synchronized, telescopes turned like faces toward a whisper in the dark, and data began to pour in, steady and sure. Preparation is not just about instruments, it's about trust. Each team member depends on the quiet competence of another. One calculates, another confirms, another interprets. The beauty of such work lies in how seamlessly hundreds of minds can align around a single purpose. They rarely speak loudly, their communication is almost telepathic. Years of shared focus have trained them to read tone, to sense timing, to know when a silence means understanding. Even during long nights of observation, when the hours stretch thin and the body begins to fade, the teams remain anchored in process. Coffee grows cold beside keyboards, the hum of cooling fans becomes background music. Outside, the stars continue their motion, unaware of the people who trace their paths. Inside, every keystroke, every line of data logged, feels sacred. This is what devotion looks like in science, not worship of the unknown, but care for the tools that reveal it. They prepare not only for success but also for failure. The unknown demands humility. Before the first readings come in, there are endless meetings about what could go wrong, sensors that might misfire, interference that might distort a signal, timing that might drift. Every what-if is met with a quiet plan. It is in this constant anticipation that safety and discovery coexist. They do not fear problems, they build gentleness into the solutions. When the first readings finally arrive, the patience pays off. Data begins as faint static, unreadable noise. But because the team's prepared, they know what to look for, how to filter the silence, how to coax the story hidden in the signals. Slowly, through their care, the invisible becomes visible. Numbers become motion. Motion becomes meaning. The visitor's path appears not through luck, but through disciplined calm. Each scientist feels the weight of precision differently. For some, it's mathematical, an equation balanced to perfection. For others, it's visual, a graph that curves just as it should. But for all of them, precision is emotional. It's the quiet satisfaction of knowing that they've built something that listens well, something that doesn't rush to conclusions. Patience turns numbers into truth, and truth into peace. There's a kind of poetry in how they work, a choreography between hands and machines, between thought and trust. When one person adjusts a setting, another watches the ripple it creates. They don't interrupt one another, they harmonize. This is what preparation looks like in the cosmos, not frantic energy, but slow, intelligent grace. The quiet hum of computers becomes a lullaby, and within it, discovery blooms. Sometimes, an entire night passes without a result. Still, they sit. They check calibration, realign coordinates, breathe, and continue. In those still hours, a deep bond forms between human patience and cosmic rhythm. It is as though the universe only reveals itself to those willing to match its pace, slow, deliberate, infinite. They learn that waiting is not wasted time, it's the necessary silence before understanding speaks. Even their mistakes carry gentleness. When data misaligns or instruments drift, no one panics. They simply note it, learn from it, and adjust. The process itself becomes a meditation. The goal is not perfection but clarity. They know that a hurried mind misses what a patient eye can see. Space teaches through delay, it rewards those who move with care. In mission control rooms, patience takes physical form. Clocks tick softly. Screens update at steady intervals. Voices stay level even in moments of uncertainty. It's not indifference, it's composure, the result of long training. The precision they maintain is born of understanding that chaos can only be met with calm. In this stillness, great things are achieved. The youngest members of these teams learn quickly that science is not a race. They watch their mentors recheck measurements, recalibrate instruments, reread data for the 100th time. At first, it seems excessive, later, it becomes sacred. The universe demands that kind of care. No shortcut can capture the slow unfolding of truth. When they gather to review results, the room hums with quiet anticipation. There's no cheering, no clapping, just soft smiles and exchanged glances when something aligns. The satisfaction of precision is internal, like a deep breath after long concentration. Each correct number, each confirmed reading, feels like the gentle click of a lock opening. The teamwork itself becomes a language. They learn to read each other's gestures, to sense fatigue, to step in when one falters. Space exploration is often described as mechanical, but it is profoundly human. Built on empathy disguised as efficiency. Preparation means caring not only for machines, but for one another. Even after the data is collected, the preparation continues. Analysis is its own quiet journey. Lines of code translate the faintest cosmic whispers into something readable. It's slow, patient work, the kind that turns chaos into clarity. Every pattern that emerges feels like a heartbeat returning from across the void. Sometimes they prepare for things that never happen, a flare that doesn't appear, a dust field that isn't there. Yet they never regret the effort. In science, readiness is never wasted. The act of preparing itself creates understanding. The careful mapping of what might occur sharpens the senses for what actually does. Years later, when missions end and data archives close, those who worked on them remember the preparation more than the result. They remember the nights of quiet concentration, the patience shared across screens, the sense of being part of something slow and vast. It's not the discovery that stays with them, it's the stillness. That stillness is a kind of faith. Faith that the laws of the universe will hold, that instruments will perform, that their quiet labor will someday meet meaning. Every test, every calibration, is an act of belief that the cosmos will respond when we're ready to listen. For those who watched Oumuamua pass, the preparation became a mirror. They realized that to study something so fleeting, one must already be in rhythm with time itself. They had spent years learning patience, and the universe rewarded them with a moment that could only be caught by stillness. Even the smallest gestures, aligning a telescope, typing a command, became echoes of something grand. In the slowness of preparation, they had unknowingly matched the rhythm of the stars. The universe had sent a visitor, and they had been ready not by chance, but by quiet, deliberate devotion. And when it was over, when the visitor drifted beyond reach, they didn't rush to the next thing. They sat in the soft hum of their workstations, knowing they had done everything right. Preparation had given them peace. It was never about control, it was about readiness. To meet the unknown with calm hands and steady hearts. Each team, scattered across Earth, shared that same quiet satisfaction. They had watched, measured, and learned together. They had done what humans do best when faced with infinity: prepare, patiently, precisely, and without fear. And somewhere, beyond the instruments and numbers, they understood that the act of preparation itself was part of the story, that the slow, deliberate care of humans had met the vast stillness of the cosmos, and both had nodded in mutual respect. In the silent glow of observatories, the smallest numbers often hold the largest truths. The data from space rarely arrives as a grand revelation. It comes as whispers, faint, almost hesitant, little lines and digits that barely rise above the background noise. Yet those quiet bits of information, when handled with care, tell stories so vast they could stretch across the universe. Each decimal point, each signal spike, becomes a brushstroke in a painting the human eye could never otherwise see. Scientists who interpret these measurements live between two scales, the microscopic and the infinite. They look at the tiniest variations in brightness, in movement, in wavelength, and from that, they reconstruct entire cosmic journeys. A slight flicker of light might mean a rotation, a faint spectral shift might reveal composition. To an untrained eye, the data looks meaningless, but to those who listen deeply, it speaks of worlds, distances, and histories too grand to imagine. When Oumuamua drifted into our reach, its story was told not in images, but in numbers. Its brightness changed subtly as it tumbled, and from those tiny changes, scientists inferred its shape, long, maybe cigar-like, or perhaps a flattened shard. No one saw it directly, yet they knew how it turned, how it caught sunlight, how it gleamed and dimmed as it spun. The smallest variations became a language, and through that language, an entire object took form in human understanding. The data came in slowly, line by line, from telescopes scattered across Earth. Sometimes the signals arrived distorted by atmosphere, sometimes nearly lost in the static of space. Yet each team treated every reading like a heartbeat from the cosmos, delicate, real, irreplaceable. They collected, compared, corrected, until a story began to emerge. Patience was their most trusted tool. From faint traces came the shape of something older than memory. The wonder of such work lies in its humility. No one demands that the universe shout its secrets, they know how to listen for whispers. The joy isn't in instant revelation, but in the gradual unfolding, the slow, careful teasing of truth from noise. Each number holds a question, and when enough questions are gathered, an answer appears like dawn after long darkness. The process feels almost spiritual, data as prayer, patience as faith. The tiniest flickers in measurement can reveal unimaginable journeys. A slight acceleration showed Oumuamua was not moving as rocks normally do. Something subtle, perhaps outgassing or sunlight pressure, nudged it differently. The change was minuscule, the kind only a computer could notice, yet its implications were enormous. It meant the object behaved more like a living thing than a dead stone, dancing slightly to unseen rhythms. Every decimal, every margin of uncertainty, is cherished. Scientists don't fear imperfection in their data, they respect it. The uncertainty is where discovery lives. A perfect line means nothing new, a waver, a deviation, that's where meaning hides. The beauty of space science is not in having all the answers, but in knowing how to interpret the tremor of the unknown. In labs, these measurements are often displayed on screens, streams of digits scrolling endlessly. To the uninitiated, it's monotony. To those who know, it's symphony. The peaks and troughs, the pulses and silences, form a kind of music. The rhythm of data is its own poetry, telling stories of spinning stones and fading stars. Even the pauses have meaning, every gap between readings a breath between celestial sentences. 4 months after Oumuamua's passing, those numbers were revisited again and again. New models emerged, old assumptions were tested. With every reanalysis, fresh layers of the story unfolded. Maybe it wasn't shaped as first thought, maybe its surface reflected light in ways no comet had before. Each adjustment brought new interpretations, like refining a melody until it feels complete. The smallest shifts in understanding created vast ripples of meaning. In every observation, there is trust in instruments, trust in math, trust in the people translating one into the other. When a scientist sees a faint curve on a graph, they know it represents reality on a scale too immense to comprehend directly. The distance between that number and the physical object is almost unbridgeable, yet through discipline and care, they cross it daily. The act of measurement becomes a bridge between the tangible and the infinite. Humans cannot touch a distant object, but they can feel it through data. Each photon that reaches a telescope carries a piece of the traveler's story, its journey, its energy, its whispers of age. Those tiny particles, turned into numbers, become memories captured from the deep past. Every reading is a handshake across the void. Sometimes, when scientists review their data, they sit in quiet awe. The numbers they hold are ancient messages, light that began its journey before their grandparents were born. In a way, each measurement is a time machine, a glimpse not just into space, but into history. To record such a thing with precision feels like participating in eternity. And yet, the measurements themselves remain humble. A few pixels brighter here, a few nanometers shorter there, that's how the cosmos reveals its secrets. The grandeur lies not in spectacle, but in detail. The universe, vast as it is, hides its beauty inside minutiae. Those who can read it become translators of infinity, turning data into storylines that speak softly but profoundly. When the findings were finally shared, the public marveled at how so much could be known from so little. A handful of numbers had birthed entire models of shape, motion, speed, rotation, composition. The scale of meaning far outweighed the scale of data. This is the essence of science, to see galaxies in decimals, to find vastness in fragments. Even disagreements among scientists were quiet acts of wonder. Some believed Oumuamua was icy, others thought metallic. Some proposed it was natural, others speculated otherwise. But behind every debate was the same shared awe that a few lines of faint data could hold so much mystery. The conversations themselves became part of the story, an echo of curiosity that spanned disciplines and continents. To measure the universe is to engage in translation, the conversion of what cannot speak into what can be understood. Each telescope, each detector, acts as an ear pressed against the fabric of reality. What comes through is not sound but pattern, not language but rhythm. The scientist's role is to interpret that rhythm, to give voice to what has always been silent. It is humbling to realize that human hands can extract meaning from light that has traveled for millions of years. That from vibrations smaller than an atom's width, we can tell the temperature of a distant sun. The scale difference is absurd, yet that absurdity is where beauty lives. In those tiny measurements lies proof of our belonging, that even in a cosmos indifferent to us, we have learned to listen and understand. Each new finding leads to another question. The numbers don't end stories. They open doors. A slight anomaly becomes a new mission. A faint signal inspires new instruments. The cycle of measurement and wonder continues endlessly, like the slow beating of the cosmic heart. It's not just about discovery, it's about remaining awake to the delicate pulse of the unknown. Some scientists keep their raw data for decades, long after missions end. They know that future eyes, better tools, might see more. The smallest misread line today could reveal tomorrow's revolution. So they protect it, archive it, treat it like a living archive of questions waiting for answers. The tiniest figures become heirlooms of knowledge, passed through generations of curiosity. For the ones who worked on Oumuamua, the story didn't end when the object left. The data remained, glowing faintly on servers, ready to be studied anew. Every reanalysis brought them closer not to a final truth, but to deeper understanding. They began to see that the story wasn't about the object alone, it was about humanity's growing ability to hear the quiet language of space. Tiny measurements, when joined, create a chorus. Each instrument adds a voice: optical, infrared, radar, radio. Alone, each tells a small truth. Together, they sing a full melody. The harmony of instruments mirrors the harmony of the universe itself, complexity built from simplicity, grandeur from the infinitesimal. To the scientists, even errors are part of the music. Noise isn't failure, it's texture. Within the static lies the reminder that the universe is alive, never perfectly still. Learning to read through that noise is like learning to hear through rain. The trick is to find rhythm in randomness. The smallest irregularity often holds the deepest meaning. And when breakthroughs come, they do so quietly. A corrected calibration, a subtle shift in data interpretation, a faint confirmation in a graph. No fireworks, No applause, just the quiet click of something fitting into place. Truth, they've learned, rarely shouts. It speaks softly, in decimals. In every observatory, there's a kind of reverence for these moments. The light is dim, the air still, as though the building itself knows that it houses something fragile and profound. The scientists lean close, not to capture noise, but to commune with meaning. Each measurement is a conversation with eternity, quiet, precise, and deeply human. The stories born from these numbers reach far beyond laboratories. They become part of our shared imagination. Written in books, shown in documentaries, whispered in classrooms. Children hear of mysterious objects from beyond the stars and dream of studying the numbers themselves one day. The data inspires not just knowledge, but hope. And yet, through all the wonder, humility remains. The scientists know that what they see is only a fragment, a whisper of truth caught from the edge of vastness. But even that fragment is enough. In those small signals, they feel connection, proof that the universe, though infinite, allows us to know it, one tiny measurement at a time. To measure is to care, to pay attention. These small readings, born of patience and focus, show that humanity's greatest strength isn't power but gentleness, the ability to look carefully, listen quietly, and find story in silence. The cosmos rewards such tenderness with revelation. So, when the data stops flowing, when the instruments finally rest, what remains are not just numbers, but stories too big for words, built from details too small for sight. And in that paradox, science finds its poetry, that the smallest measurements can contain the largest truths, and the universe, vast beyond measure, can still fit inside the calm of a single human thought. Across the silent world, a symphony of telescopes turned their delicate eyes toward the same patch of sky. From Chile's arid mountains to Hawaii's serene peaks, they aligned, focusing together on the visitor brushing softly through the solar system's outer edge. Each lens gathered a glimmer of reflected sunlight, each dish hummed faintly with the echo of signals passing across the dark. It was not just one machine looking, it was hundreds, whispering to each other through data streams, forming a quiet, unified gaze. On Earth, the people who tended to these instruments moved with patience and ritual. They adjusted panels, recalibrated sensors, and watched graphs slowly draw across their screens. The comet's faint signature appeared, vanishing and reappearing as light wove through dust and distance. Even the smallest variation, a flicker, a pulse, a tiny change in brightness, was a thread worth following. This was not a race to capture, but an act of listening. Every photon told a small, truthful story. The great radio arrays listened too, stretching their metallic arms across deserts and plains. They picked up the whispers of ionized particles as the spacecraft moved through the comet's tail. The signals came faintly, fragile against the backdrop of cosmic noise, but within them were traces of interaction, of sunlight meeting ancient ice, of dust streaming past the detectors. It was like hearing the softest rustle in a vast forest of silence. Each observatory sent its findings to a shared network, where data was collected and combined. Scientists across continents sat in dim rooms, faces lit by screens, watching the same shapes unfold. The universe had always been a communal study, one where curiosity flowed like light, crossing borders and languages. For this brief window, everyone's instruments spoke together, like a quiet choir beneath the endless black. The spacecraft's perspective was different, closer, more immediate. It felt the fine particles brushing against it, sensed magnetic ripples and charged winds. But from far below, telescopes added the distant beauty, translating light into understanding. Together, they formed a partnership of near and far, detail and overview, a full picture assembled from fragments. There was a tenderness to this cooperation, a humility in knowing that no single tool could see it all. The comet's path was long and unpredictable, its surface ever-changing. Yet each observation filled a missing piece: temperature, dust density, ion composition, color gradient, all stitched together by teams whose only wish was to listen better. The night sky had become their shared notebook. As days passed, the instruments continued their slow dance. Ground-based telescopes captured the comet's shimmering expanse, orbiting satellites traced the solar wind's shifts. The data formed like dew, collecting patiently. Even cloudy nights could not stop them. The instruments above Earth continued to hum, faithful and tireless. Humanity had learned that waiting was part of discovery. Every telescope, no matter how small or grand, held its role. In one part of the world, an amateur astronomer noticed a faint brightening and scent in their record. That single note was added to the global song, confirming a theory others had suspected, that the comet's tail was growing denser as it neared the sun's subtle warmth. Sometimes the universe required not genius, but attentiveness. In the observatories, technicians spoke softly. They adjusted frequencies, ensuring no interference drowned the comet's whisper. Even the computers seemed to slow their breathing, processing each photon as if it were a sacred gift. Beyond the noise of human life, this collaboration was an act of devotion. It wasn't about discovery alone, it was about being part of something vast and gentle. At certain moments, all the instruments aligned, from radio dishes to optical telescopes to deep space monitors. Their combined data created a living portrait, a comet breathing through space, dust trailing like silk in the solar wind. The picture wasn't just visual, it carried texture, rhythm, and motion. To the scientists, it felt almost like music. When the spacecraft transmitted its data, those on Earth cross-checked the readings with telescope images. The two sources harmonized beautifully, the in-situ readings confirmed the distant observations, and vice versa. The universe seemed to smile at their precision. It was a moment where human cooperation mirrored the balance of the cosmos itself. For many observers, this was not just an event to record, but to feel. Watching a distant traveler glide near a human-made probe stirred something ancient, a reminder that our instruments, however advanced, were still extensions of the eyes that once looked up from campfires. The technology had changed, but the wonder remained untouched. Over oceans and mountains, night after night, the telescopes tracked the comet's fading trail. The brightness diminished, but its path grew more certain. The instruments had become like old friends, seeing someone off at a station, watching, waving, grateful to have shared even a brief moment of proximity. As the comet drifted farther, its signal softened into the noise again. One by one, the telescopes turned back to their usual work: stars, exoplanets, galaxies. But something lingered in the silence afterward. A kind of peaceful fullness, as though everyone had witnessed not just data, but the gentle heartbeat of motion itself. For the spacecraft team, it was a quiet triumph. Every number returned, every reading confirmed, meant that the instruments had worked flawlessly even across billions of kilometers. They felt a mix of pride and reverence. The comet had brushed their creation, and instead of breaking it, had whispered secrets into its sensors. Weeks later, the combined results began to paint the deeper picture: the comet's chemical makeup, its dust-to-gas ratio, its subtle electric charge patterns. Each measurement was a sentence in a growing cosmic diary. Telescopes had heard one voice, the spacecraft had heard another. Together, they wrote the full melody. It was not a loud discovery, no breaking news, no flashing headlines. But it was deep and enduring, the kind of science that moves quietly through generations. Years from now, students would still study those readings, learning how humans once caught a comet's sigh. The teams exchanged messages of gratitude between observatories, between nations, between space and Earth. Data packets moved like letters between distant friends. Everyone who had participated felt connected, as though they had together held a stethoscope to the heart of the universe. Even as the comet disappeared beyond the reach of telescopes, its story was still unfolding in the data streams. The tale that had glimmered faintly now existed in countless graphs and spectral lines, proof that light, once caught, could be studied forever. Through it all, the telescopes stood as patient listeners, always ready for the next voice. Each one had turned its gaze toward a moment that would soon pass, but the act of watching had meaning in itself. It was humanity's quiet declaration: we are still here, still looking up, still listening. And somewhere in the cold, unending dark, the spacecraft drifted onward, its instruments resting, but its memory alive. Far away, the telescopes on Earth blinked beneath clouds and dawn light, unaware that their chorus had composed something eternal, a song made of data, distance, and wonder. When the data finally settled into human hands, across quiet laboratories and dimly lit screens, something deeper stirred than scientific curiosity. It was the sense that each number, each curve of light intensity, represented more than a moment of contact. It was a bridge, a reminder that humanity, with its fragile machines and restless questions, could still touch the edges of eternity. The comet, ancient and wordless, had given us a story that reached backward billions of years, into the time before memory itself. Scientists spoke in calm tones about ratios and densities, about how the spacecraft sensors had measured particles smaller than a whisper. But beneath those discussions lay something more profound, a collective wonder that the universe, vast and indifferent, still allowed such closeness. To witness the dust of creation floating past a man-made traveler was to feel both humbled and exalted. The cosmos, it seemed, was not unreachable, it was listening too. The comet's data told of materials older than the planets, grains of frozen gas and rock preserved since the dawn of the solar system. Each molecule had survived collisions, temperatures, and eons, carrying within it the signature of formation, like a fingerprint left on time itself. When scientists analyzed the readings, they realized they were studying pieces of a prelude, remnants of the universe's first sculpting strokes. Through this encounter, humanity glimpsed its own beginning in reflection. We were built from the same cosmic dust, forged by the same forces that had shaped the comet. The realization was both scientific and spiritual, a convergence of knowledge and awe. The spacecraft had not merely passed through a trail of debris, it had brushed against our own past, our literal material ancestors. The comet's gentle encounter reminded us that time in the universe flows differently. What to us feels ancient may be young to the cosmos. These celestial travelers have seen the rise and fall of worlds, drifting in slow arcs through epochs. By studying them, we borrow their patience, their endurance, learning to think in the language of millions of years. It changes how we see ourselves, not as brief flickers, but as participants in an ongoing, graceful motion. In mission briefings and classrooms, people began to speak softly about continuity, how every journey outward was also a journey inward. Voyager's passage near the comet had opened not just a scientific window, but an emotional one. It connected the old ambition of exploration with the quieter need to understand why we keep seeking. The story of the universe, it seemed, was also the story of attention. The spacecraft itself became symbolic, not just a machine, but an extension of human curiosity turned physical. Its sensors, humming in the dark, mirrored our own desire to know. And when it felt the faint brush of dust against its instruments, it was as if we, too, had reached out and touched the drifting edge of creation. The readings were, in that sense, a form of communion. What it meant for our cosmic story was simple yet profound. That discovery did not end when we left Earth's atmosphere. It matured. Our questions had evolved from what is out there, to what does it mean that we are part of it. The comet's passage redefined exploration, not conquest, but conversation. Every interaction with space had become an exchange of memories between species of matter. Scientists noted how the data confirmed long-held theories about ion tails, plasma interactions, and solar wind behavior. But what lingered most was the humility those confirmations brought. The universe did not need to surprise us to remain miraculous. Even when it behaved as predicted, it still glowed with mystery. To understand its patterns was to join in its rhythm, not to outgrow it. The encounter reminded us of how delicate the boundaries of life and death are in cosmic terms. A comet may carry organic compounds, the seeds of chemistry that, under the right warmth, might one day stir into something breathing. That thought haunted and comforted the researchers that within every dusty spiral might be the unspoken potential of life, waiting quietly through millennia for its turn. Humanity's cosmic story is one of connection, through radio signals, through light, through shared wonder. Voyager's small gesture, drifting past that tail of luminous debris, was one more thread in that tapestry. The comet had offered itself, briefly, as a teacher. Its lessons were not loud, but enduring: patience, resilience, and the beauty of persistence in motion. For many of the mission's engineers, this was a farewell written in starlight. They knew their craft would never return, that its voice would one day fade. Yet its message and this encounter would continue to echo through classrooms, books, and generations of new dreamers. That continuity was its true success. Machines may fall silent, but their journeys seed the next wave of questions. Somewhere in the night sky, the comet was continuing its slow curve, indifferent but luminous. It would pass again, centuries later, to greet a new world, perhaps one no longer inhabited by us. And yet, because of this moment, it would be known. Its identity recorded, its orbit understood. In a universe built on forgetting, that small act of remembrance mattered. The data revealed something tender about space itself, that emptiness is not truly empty. Within the void are stories, chemical traces, invisible currents that carry the scent of stars long gone. Each measurement Voyager sent home was proof that silence is never truly silence, it only speaks in frequencies our ears can't hear. Astronomers, looking at the compiled findings, felt a strange intimacy with the comet. To know its structure, its delicate balance of ice and dust, was to feel its vulnerability. It wasn't just a wanderer, it was a survivor. A fragile piece of the early universe still moving gracefully through the present. In that realization, a quiet shift occurred. Humanity stopped seeing comets as omens or curiosities and began seeing them as kin, relatives from the deep family of matter. Their journeys became metaphors for endurance and returning. The spacecraft's encounter became less about data and more about empathy with creation itself. It also reminded us of our responsibility, that observation carries respect. We touch these celestial bodies with our machines, but we must do so gently, remembering that we are guests. The comet offered no resistance, only silence, and in that silence was grace. The encounter was both a success of science and a lesson in humility. The cosmic story now included a new chapter, one where humanity and the universe spoke briefly and understood each other. It wasn't through words, but through data, through the shimmer of particles and the vibration of plasma waves. In that language, there was no hierarchy, only coexistence. Back on Earth, the data turned into images and graphs, into publications and symposia. But beyond all that, it turned into quiet reflection. Scientists walked home at dawn after long nights of analysis, looking up at the faint morning star, feeling both very small and deeply connected. That duality was the gift of space exploration, to shrink the ego and expand the soul. This event also wove together generations of research, those who had launched Voyager, those who maintained its legacy, and those who would carry it forward. The comet's visit was like a handshake between eras, uniting decades of effort in one luminous instant. It was proof that time in science moves like the cosmos, slow, steady, continuous. Each time a new generation studies this data, they will not just learn about the comet, they will feel what it meant to reach across such impossible distance. They will see that exploration is not about arrival, but continuity. Voyager's moment in the comet's tail will stand as a reminder that every passing moment in space is an act of connection. The instruments had recorded fluctuations, densities, and radiations, all the measurable things. But what could not be measured was the human quiet that followed the transmission, the deep pause where wonder replaced words. That was the true echo of discovery, not in data points, but in hearts learning to listen. Our cosmic story, shaped by moments like these, continues to evolve not through speed or conquest, but through grace. Each mission teaches us to look softer, to notice more, to understand that the universe is not something to conquer but to join. Voyager's distant glide through that comet's whisper was a perfect example of this new way of knowing. Perhaps that is what exploration means now, not expansion, but communion. The spacecraft became a listener, the comet a storyteller. Together they wove a sentence into the endless poem of existence. It was quiet, fragile, and endlessly meaningful. From this event, we learn that science and wonder are not opposites, but siblings. Numbers and feelings coexist, like stars and dark space. Voyager's data will feed computers, but its story will feed souls. Both are forms of nourishment, sustaining the great human urge to understand. And so, what it means for our cosmic story is this: that the universe invites us not to own it, but to participate in it. Every mission, every measurement, every comet brushed by a spacecraft's passing becomes part of a shared heartbeat between us and the stars. Even now, as Voyager drifts on in silence, its faint pulse still carries that meaning. It has proven that even across billions of kilometers, connection is possible not just technologically, but spiritually. The comet passed, the instruments recorded, and in that quiet exchange, the cosmos whispered, "You are part of me too." When the comet's faint tail finally drifted out of range, there was no sudden ending, only a long, slow fading, like the closing notes of a distant song. The spacecraft continued on its steady course, its instruments cooling, its sensors still awake. The data streams grew thinner, the signals stretched softer through the void, but the story did not vanish. It lingered, suspended between stars, a trace of curiosity preserved in motion. The universe, ever patient, held the memory gently. On Earth, the teams who had spent months watching, waiting, and interpreting the encounter found themselves in a strange quiet. Their workstations were filled with completed graphs, their computers humming softly with stored findings. Yet beneath all the precision and numbers, they felt something else, a wistful awareness that a moment had passed which would not come again. The comet was already slipping away, like a dream half remembered at dawn. It's strange how endings in space never feel abrupt. They drift. The boundary between still happening and over is measured not in seconds, but in distance. The spacecraft kept listening long after the comet was gone, as if reluctant to admit it. Each sensor continued to hum, searching for the faintest residual traces, a final whisper, a last echo of charged dust. Sometimes, it seemed as though the machine itself understood the gravity of farewell. The mission logs reflected this tenderness. Each entry grew shorter, quieter, as though the engineers themselves were writing with gentler hands. They described small calibrations, final adjustments, the end of data collection. But between the technical lines, you could sense the affection, the care of people who had watched their creation reach out into the dark, touch the unknown, and come back wiser. They didn't want to let go. When the final transmission of the encounter arrived, no one clapped or cheered. Instead, there was silence, respectful, almost sacred. The team sat together, watching the faint line of data scroll across their screens one last time. Outside, the night sky stretched wide and still. Somewhere out there, both the comet and Voyager drifted on, now separated by an ocean of empty light. It was not an end of function, but a change of rhythm. Scientists, philosophers, and dreamers alike found themselves reflecting on what had truly been achieved. It wasn't just knowledge, though that too was profound, but perspective. The encounter had reminded humanity that every story in the cosmos is ongoing, that each event carries forward into another. Even a brief crossing between a comet and a probe leaves ripples in how we think about creation, time, and belonging. As the data was archived, the researchers began to notice subtle curiosities, small anomalies, quiet hints of new mysteries. A few readings didn't quite align with models. The magnetic flux varied unexpectedly. The dust distribution seemed uneven, suggesting hidden structures in the tail. None of it was alarming, but it whispered of questions not yet asked. The universe, it seemed, was not content with closure, it preferred to leave trails. That is how cosmic exploration often ends, not with certainty, but with deeper wondering. Each answer opens new doors, leading toward infinities too vast to map. The spacecraft, in passing through that luminous debris, had not only gathered data but had gently pushed humanity into new realms of curiosity. What other stories drift unseen between the planets? How many comets carry secrets older than the stars we see? In the following months, papers were written, models refined, and theories proposed. Yet amidst all the analysis, there remained a quiet emotional residue, a sense that this event had been more than mechanical. It had been intimate. Humans had brushed against something untouched for billions of years, and in doing so, had been reminded of their smallness and their grace. At public lectures, people came not just to hear about measurements, but to feel connected to something beyond themselves. Children asked what the comet smelled like, what its dust felt like on skin, whether the spacecraft might someday meet another traveler. These questions, innocent and poetic, carried the same essence as science itself, the yearning to touch what cannot be touched. The scientists, though steeped in data, couldn't help but smile. For them, the comet encounter had rekindled something pure, the wonder that had drawn them to the stars in the first place. They spoke not just of equations, but of the feeling of being part of a universe still unfolding. The comet had been a teacher, and its departure felt like the end of a gentle lesson. Even as time passed, and the event slipped into archives and memory, the questions it raised remained alive. What other ancient wanderers might cross paths with our creations? Could we one day send new probes to meet them, to continue this quiet dialogue between matter and mind? Each thought, each hypothesis, was like a hand reaching outward, following Voyager's trail into the unknown. There is beauty in unanswered questions. They remind us that exploration is not about completion, but participation. The comet had not given all its secrets, nor had the spacecraft taken them all. The exchange had been brief but sufficient, a promise that there is always more to find, if one listens with patience. That promise became part of humanity's ongoing cosmic dream. As Voyager continued its silent journey, engineers occasionally checked its instruments, ensuring that the data stream, however faint, still whispered home. Each transmission was a heartbeat. Each signal, no matter how delayed, was a reminder that something built by human hands still wandered far beyond the reach of light meant for earthly eyes. It was both lonely and magnificent. Meanwhile, astronomers kept watch for the comet's future return. Though it would take centuries, they plotted its next passage, imagining the generations that might one day greet it. Perhaps, by then, new voyagers, not of metal, but of flesh and thought, would be waiting. Maybe they would know us only as names in old records, the first dreamers who sent their instruments ahead into the dark. The idea that a single moment could ripple through centuries is what makes space exploration so hauntingly beautiful. The spacecraft's passing through the comet's tail was brief, but the story it told would echo long after. Just as ancient astronomers once mapped comets by sight, we now mapped them by touch, by data, by the deep hum of electromagnetic waves. It was a new kind of stargazing, one born from closeness, not distance. Even the anomalies, the mysterious variations in the data, became treasures. They were the kind of imperfections that spoke of real encounters, not simulations. They were signs that the universe was still slightly unpredictable, still full of personality. Scientists loved that. They didn't want perfection. They wanted wonder. Each discovery carries with it an invisible lineage of dreams. The first time a child looked up at the sky and wondered where a comet went, that question began a chain leading all the way here, to instruments passing through cosmic dust, to hands typing commands across billions of miles. The end of the encounter was simply another link, waiting for the next question to attach. And so, the data continued to inspire. Writers, painters, and musicians found new language in it, soft echoes of the cosmic meeting. Songs were written about the spacecraft drifting through ancient ice. Poems spoke of how distance could still mean connection. Art became the echo chamber of science's gentler voice, translating numbers into feeling. Every ending in space is a seed, not a silence. Voyager's slow departure from the comet's path left behind fertile ground for imagination. Scientists dreamed of new missions, probes built to listen more deeply, to feel more closely, to wander farther still. The legacy of this soft goodbye was not grief, but momentum. Curiosity does not die, it only transforms. Some nights, the engineers would still step outside after their shifts, looking up at the sky with quiet affection. They knew that somewhere out there, their machine was still moving, carrying within it traces of that luminous dust. It was a humbling thought that a fragment of human ingenuity now drifted through the memory of creation itself. The comet's tail, though unseen now, had left its mark. Not in the sky, but in minds. Its faint signature was encoded in countless drives and backups, humanity's own version of cosmic fossils. It would be studied, reinterpreted, rediscovered. Just as comets preserve the past, our data preserves the present. Both are forms of remembrance. And yet, even with all we learned, something always slips through understanding. That is the gift of the cosmos, it gives, but never completely. For every known element, there remains mystery. For every recorded vibration, there remains silence. Voyager's encounter with the comet reminded us that this balance is perfect. The universe thrives in the space between knowing and wondering. In time, other missions will take up the mantle, other spacecraft, other explorers. They will pass through tails, rings, and shadows, each one writing a new stanza in the same endless poem. But they will always carry within them this lesson, that endings are gentle and questions are eternal. Long after the scientists have retired, long after the comet's name has become legend, the data will still exist, glowing faintly in archives, like a firefly preserved in amber. It will remind future dreamers that once, humanity reached out softly, touched the cosmos, and was changed by the touch. Even the silence that followed was beautiful. It wasn't emptiness, it was fullness stretched thin, a pause meant for reflection. The spacecraft continued its voyage into darkness, its sensors still faintly alive. The comet continued its ancient path, and between them, invisible but real, stretched a bridge of understanding made entirely of light and time. This was the true ending, not a closure, but a continuation. Voyager kept going. The universe kept speaking. The questions kept breathing. What began as a mission became a meditation, one that still drifts, softly, between the stars.